Alexandria stood on a low coast where ships entered long, sheltered waters. Around c. 300 BCE, a teacher named Euclid worked in a quiet room near the royal quarter. The film set its focus on his steady labor, arranging geometry as a clear system. Papyrus rolls rested beside a straight edge and a compass. Wax tablets kept small notes that could be smoothed and used again. Outside, a faint sea breeze moved past lattice shutters. Inside, paper rustle and light steps set a calm pace. The workroom held simple tools that shaped exact ideas. A straight edge, an unmarked ruler for drawing lines, lay on a flat board. A compass, a pivoting tool for circles, folded into a cloth wrap. Reed pens drank thin ink from a small jar. Dry sand fixed wet strokes on papyrus. A plumb bob hung from a peg to set an upright. A sponge cleaned chalked figures from a board. Light from an oil lamp steadied across the table edge. The room stayed plain and ordered, with little to distract the eye. Euclid's aim was simple and strong. He set geometry on firm ground, then moved in short, linked steps. The plan began with definitions, postulates, and common notions. A definition named a thing, like point, line, or angle. A postulate, a rule accepted without proof, allowed one to draw a line or a circle. A common notion, a general rule about equals, guided sums and differences. By setting these first, later work could proceed without constant change. Pens marked neat columns, pages turned without hurry. The elements formed the core text. It likely filled several roles, later called books, arranged in a careful order. Early parts fixed triangles, parallels, and circles. Later parts treated ratio, number, area, and solid forms. Each result leaned on earlier results, forming a chain that held. A line began with let and ended with therefore, always within the first rules. Nothing loud appeared in the language. Clarity carried the weight. Reed pen strokes sounded light. A small weight held a sheet from curling. Teaching followed a repeatable day plan. In the morning, figures from the previous day were redrawn with fresh chalk. Names for points used short letters to keep lines clear. Given data and the goal stood in separate lines. Midday brought constructions and checks. In the later hours, students copied fair versions on papyrus. Short rests came as sand-fixed ink. The room stayed cool from thick walls. The air held a hint of oil and fiber. The pace remained even and measured. A proof was a chain of clear steps that showed why a claim was true. It began with known data and allowed moves from the postulates. Construction steps placed helper lines made only by straight edge and compass. Justification cited earlier results or the general rules. Each step removed doubt without force or show. If a line bisected an angle, the reason was named. If two triangles matched, the shared cause was set out. Chalk dust lifted, then settled into quiet corners. Constructions formed a second steady track beside proofs. A construction meant building a needed figure from the postulates alone. With two tools, one could copy a length, mark a midpoint, or raise a perpendicular. The compass clicked softly as its point found the board. The straight edge's edge slid to a mark, then stopped. A light hand made the line. Nothing on the tool carried numbers. The work relied on shape and relation. These steps turned rules into working actions, fit for daily use. The matter of parallels called for special care. One postulate allowed exactly one line through a point to run parallel to a given line. From this, many quiet facts followed. Equal angles across a crossing, triangles with set sums, and stable distance lines. Some earlier writers avoided this rule. Euclid said it plainly, but used it with restraint. He placed it where needed and no more. Students watched pairs of lines meet or not meet on the board. The room kept a low hum of thought. Ratios and proportion extended geometry beyond simple whole counts. A ratio compared magnitudes that might not share a single small unit. A proportion stated that two ratios matched. Euclid's method handled such cases without fractions in the modern sense. Chords and pebbles sometimes helped illustrate equal steps in measure. A counting cord slid between marks with a dry rasp. The approach let areas and volumes be compared by logic, not by guess. Lines and regions kept their places in order. Work in the room touched other crafts nearby. Surveyors stretched cords to fix fields and walls. Builders used similar triangles to plan ramps and sight lines. Stargazers set right angles and level planes for sky tools. The elements did not teach these jobs, yet it supplied stable steps and checks. A plumb line took wind and returned to stillness. A set square hugged a corner. Quiet notes marked which lemmas were needed for a task. Reasoning stayed at the center of the work. Copying and storage were part of the same calm system. Scribes trimmed papyrus sheets to a common width and joined lengths with paste. Lines for text and figures were lightly ruled with a lead point. Titles and book numbers sat on end labels for quick finding. Rolls dried on pegs before binding cords held them. The city's bookrooms gathered such rolls for study and loan. When a copy wore thin, a new fair copy replaced it. Paper rustled as stacks shifted along the shelf. The order of topics favored learning by small, firm gains. Triangles came before polygons. Plane figures came before solids. Numbers and primes appeared where they served ratios and measure. The greatest common divisor was found by repeated subtraction, a simple, sure routine. A slate showed each step until the answer stayed fixed. Pebbles clicked into groups, then stopped moving. The method gave shape to thought and left few loose ends. Students learned to follow the same pattern in new cases. A standard way of naming parts kept confusion low. Points took short marks, lines took pairs of letters, circles took centers and radii. Angles wore small arcs and may have held numbers when needed. Figures remained large, with little crowding. When a board filled, a sponge cleared it for the next stage. The teacher's voice stayed even. Reasons sat close to the place they applied. If a claim required two earlier results, both names appeared. This prevented searching and slowed no one. The setting of Alexandria supported this kind of careful work. Ships brought fine papyrus and smooth ink soot. Craftsmen in the city shaped metal points and clean straight edges. The royal quarter offered lecture rooms and copy space. Scholars suggest a loose circle of teachers shared notes and problems. Euclid's room fit within that network without noise or show. The aim was not fame, but sound order. A light wind moved the hanging shade. A reed pen rested across a jar. Students learned by doing, not by large speeches. Each figure fixed a single idea. Each idea received a short proof. Errors were corrected with small changes, not harsh words. When a point slipped, the line erased and was drawn again. When a reason failed, the step returned to the last true place. Progress came by patient return to rules. The goal was plain sight, to see that a claim could not be otherwise. The day ended as it began, in calm method. The elements also guided how to read a page. A reader's eye moved from figure to claim, then to reasons. The figure did not prove the case, only the steps did. The figure helped the mind hold positions without strain. Therefore it stayed neat and uncluttered. Margins left space for small notes. Important lines were redrawn thicker for new readers. In this way, the page became a quiet tool, not a display. Fingers lifted a corner. The sheet lay flat again. Though little is known about Euclid's daily life, the work's tone is clear. It favors steadiness, short words, and balanced parts. It gives enough to move, not more. This helped the text travel well to later ages. Copyists in new cities could follow its order. Teachers could plan days by its steps. Students could test their own reading against its proofs. In the room, the same slow rhythm held. Oil hissed softly at the lamp's wick. The sea breeze remained faint and cool. Over time, the method reached far beyond the harbor. Later editors wrote comments and kept examples in a similar style. They changed some order, but the base frame stayed the same. The chain from first rules to later results continued to carry weight. Builders, map makers, and instrument makers found clean paths through their tasks. Still, the opening scene remained a small room, 2 tools, and a clear plan. Papyrus edges aligned into a straight stack. The day's last figure dried under a light draft. A table, a straight edge, and a compass held the work steady. Definitions and postulates came first, then proofs and constructions. Students copied, checked, and corrected in low voices. Outside, ships moved in and out of the long bay. Inside, the ordering of geometry took shape without hurry. Paper rustled softly. Sand passed over fresh ink. The room's air stayed even and cool. The method set its roots, one measured step at a time. The workroom sat behind a shaded court in early Hellenistic Alexandria. Its walls were thick, with narrow shutters to temper light and heat. A low table stood at the center on woven mats. Shelves held jars, cords, and rolled papyrus in neat rows. A chalked board leaned against one wall for figures. The air smelled faintly of oil and dry fiber. From the harbor quarter, a soft sea breeze reached the shutters and cooled the room. The table was simple and steady, built from smooth wood boards. 4 stout legs spread slightly for balance on the mats. A small plumb line confirmed the surface stayed level each week. A folded linen cloth protected finished sheets from dust. A reed basket kept pending notes together by topic. A shallow tray held sand for drying ink on new pages. When a page lay flat, the grain of the board guided a straight start. A straight edge, an unmarked ruler for drawing lines, rested along the table's edge. Its sides were checked often against a known square block. If a nick appeared, a fine file restored the clean line. Chalk rubbed along the edge to reveal uneven places. After care, the edge slid with almost no sound. When it met 2 marked points, it waited without drift. A light hand drew along it, and the line stayed true. A compass, a pivoting tool for circles, lay wrapped in a small cloth. Its legs were bronze, with 1 sharp point and 1 drawing tip. A drop of oil at the joint kept the motion smooth. The points were covered when not in use to guard the tips. Before drawing, the fixed point pressed gently into the board. The leg opened until the set length matched a mark. Metal touched wood with a light click, then swept a steady arc. Wax tablets served for drafts and quick checks before fair copies. A tablet held a thin layer of beeswax inside a wood frame. A stylus, a pointed writing tool, scratched figures and short notes. The reverse end of the stylus had a flat paddle for smoothing. Warm hands softened the wax just enough to take the mark. When a draft was done, a pass of the paddle erased it cleanly. The tablet cooled again and returned to the shelf. Papyrus sheets came from craftsmen who worked near the city canals. They cut the plant pith into strips, laid them in cross layers, and pressed them. The pressed sheet dried under weight, then was polished with a smooth stone. Several sheets joined by paste formed a roll of set width. Knife blades trimmed edges to a straight line for binding. The surface took ink well after a light rub with fine powder. Paper rustle sounded dry, and even as a sheet turned. Reed pens required small care to keep clean strokes. A fresh reed was cut at an angle, then split to make a nib. A paring knife set the width for text or for figure labels. A whetstone touched the edge between sessions to keep it sharp. A small sponge pad held water for quick rinses. Each pen sat in its own wrap to protect the nib. When a line began, the pen tip whispered against the sheet, then lifted. Ink came from soot and gum mixed with water. Lamp-black soot gathered from oil lamps gave deep color. Gum from tree sap bound the soot to the papyrus fibers. A small shell dish held the ink for a day's use. If it thickened, a drop of water brought it back to flow. When a line finished, a pinch of sand fell across it. The sand hissed softly over damp ink, then was tipped away. Pages dried flat without smudge. Layout came first, so figures would stay clear and readable. A lead point, a gray metal stylus, ruled faint guidelines for text. Margins on all sides kept notes from crowding the proofs. A light grid marked where a diagram would sit beside its steps. Center points for circles were pricked gently, never torn. Labels used small, plain letters to avoid confusion with numbers. When the plan was set, the page felt open and calm. A chalked board handled demonstrations and quick trials. The surface was renewed with a thin wash of ground gypsum. A damp sponge cleared old lines without leaving dust behind. Chalk lines began thick for placement, then were refined. Students watched the steps as each new line justified the next. When the board filled, everything paused for a careful wipe. The room returned to a pale, even surface ready for another figure. Joining papyrus sheets into rolls took unhurried, careful work. Paste spread thin along the overlapping edges, never too much. A bone folder pressed the seam flat until it held. Each finished roll wound around a small wooden core for strength. A tag along the outside named the text and its book number. Cords tied loosely to avoid creasing the writing surface. Rolls rested upright in a chest where air stayed dry and cool. Small tools kept order without notice. A set square checked right angles on boards and frames. A measuring cord, kept under slight tension, confirmed equal parts. A plumb bob set an upright line beside a diagram. A soft brush lifted grit from the table before writing began. A cloth covered open ink when the lamp was trimmed. Each tool returned to its place after use. This routine saved time and guarded every page. Light mattered for clean lines and steady eyes. In the morning, shutters opened just enough to give even light. At midday, screens cut the glare and lowered the heat. Lamps burned clear oil when clouds steeped the harbor. Wicks were trimmed with a small hook, so flames stayed small. Lamp smoke thinned near the shutter as air drifted out. The light pool across the table stayed calm and did not flicker. The straight edge and compass turned postulates into action without numbers. To copy a length, a compass set the span from the model. The same span stepped across a new line by repeated arcs. To raise a perpendicular, circles marked equal distances from a point. The straight edge connected those marks into a clean upright. Each move stayed within the allowed tools. The process taught the hands to align with the first rules. Proof notes and figure work shifted between wax and papyrus. A claim and given data appeared first on a wax tablet. Trial lines tested whether an approach would stay clear. When the steps felt certain, a papyrus sheet took the fair copy. The figure sat close, but not tangled with the text. Where a reason cited an earlier result, a short mark flagged the line. A final check read the page aloud in low, even tones. Storage rules protected pages from harm and mix-ups. Pages dried under a board until the ink cured. Rolls never lay in damp cloths or near lamp heat. A simple catalog marked where each roll rested in the chest. When a roll left the room, a slip noted borrower and date. If a seam loosened, paste in a bone folder repaired it soon. The goal was quiet continuity, not display or speed. Care of tools followed a weekly round. Edges were inspected, points capped, and wraps replaced if worn. The compass joint took a trace of oil with a feather tip. Wax tablets received a thin, fresh layer if scratched too deep. Reeds were sorted. Dull ones were trimmed or set aside. The board got a new wash when marks no longer cleared well. These small tasks kept the workday smooth and without delay. Visitors from nearby shops sometimes delivered supplies. A papyrus maker brought a batch from the latest pressing. A potter offered small lidded jars fit for ink and paste. A metalworker checked a compass point and adjusted its screw. Exchange was brief and quiet, focused on fit and function. Coins moved into a small box, lids snapped shut. Then the room returned to its measured rhythm. Season and weather shaped the routine in gentle ways. On hot days, shutters stayed narrower, and work shifted earlier. On cool days, a brazier warmed hands before careful cutting. Sea air suggested extra drying time for paste along seams. Windy afternoons carried grit, so covers lay over open sheets. The plan adjusted, but the order of steps did not change. The system held despite small turns in the day. Teaching made steady use of the same tools. Students stood by the board for a single construction. One held the straight edge, while another placed the point. A third read the next step from the wax tablet. After the figure stood, reasons followed in short lines. The chalk sponge passed from hand to hand, leaving the surface clear. Tool clinks stayed soft. Voices remained low and even. By evening, the day's pages lay stacked under a protective board. Pens were rinsed, dried, and wrapped in clean cloths. The sand tray was sifted to remove stray fibers. The lamp wick was trimmed short before flame was pinched out. Shutters moved to the halfway mark to let the room breathe. A faint breeze slipped through, and the last smoke thinned. The space rested in order, ready for calm work again. Across these steps, objects remained central and plain. A table, a straight edge, a compass, and wax tablets shaped the work. Craftsmen in Alexandria supplied papyrus, pens, and jars with regular care. Ink dried under sand that hissed softly when scattered. Nothing loud happened in the room, yet much became clear. From simple tools and patient handling, lines, circles, and proofs took form. The day ended as it began, with quiet paper rustle and even light. In early Hellenistic Alexandria, copying rooms sat near the royal quarter. The spaces were plain, with steady light from high shutters. Low tables stood in lines so scribes could work without crowding. Baskets held prepared papyrus and trimmed reeds. A chest kept approved models safe from wear. The air felt dry and calm after the sea breeze faded. Footsteps on reed mats sounded soft and even. Work began with a checked model, called an exemplar, the page to copy. Each step followed quiet rules, so every copy matched the model. The aim was clarity, not display. A senior scribe chose the day's exemplar from a tagged roll, a small slip named book and section with neat marks. The roll unfurled over a linen cloth to guard fibers. Margins were measured with a cord and a set square. Faint guidelines were drawn with a lid point. Headings were planned in red for quick finding later. Diagrams were marked out lightly before any ink touched them. The order kept text away from figures so eyes moved easily. When the layout looked calm, copying could begin. The room held its breath as first strokes started. Papyrus sheets arrived in stacks from nearby makers. Each sheet was rubbed with a smooth stone to reduce drag. Edges were checked and trimmed with a sharp knife. Dry fibers whispered under the blade in a short, even sound. 2 or 3 sheets joined to form a working length. Paste spread thin and clean at the seam. A bone folder pressed the overlap until it lay flat. The joint dried under a board for a brief span. When ready, the length moved to the table. Nothing rushed. Small delays protected the page. Reed pens were cut to suit text and figure labels. Narrow nibs handled small letters with clear strokes. Slightly wider nibs wrote headings that needed calm notice. A sponge dish held water to rinse dried gum from the tip. Ink from lamp soot and gum sat in a covered cup. A test line on scrap confirmed the flow was right. When ink seemed thick, a drop of water eased the stroke. A tray of fine sand dried new lines without smear. The sand hissed softly, then tipped away. The sheet remained clean and steady. Text came first. Then the figure followed in a planned space. A scribe read a short phrase from the exemplar. He wrote it in measured letters across the ruled line. Another short phrase followed without haste. Errors were rare because eyes moved in small steps. If a stroke wavered, it was scraped gently with a knife. The surface smoothed under a burnisher before fresh ink. A red heading, a rubric, or red label, marked a new proposition. Small letter labels prepared a place for the diagram. The page grew in order rather than in rush. Assistants managed figures with straight edge and compass. Center points were pricked lightly with a fine awl. A compass traced arcs to set equal lengths or angles. The straight edge connected marks into clear lines. The tools touched the sheet with only light pressure. A mismark was lifted from the surface with care. When finished, the figure matched the exemplar within a hair's breadth. Labels sat outside the lines to avoid confusion. A final pass checked that lines did not cross by mistake. Metal taps and pen lifts made a soft pattern on the table. Quality checks followed every completed sheet. A reader compared line by line against the exemplar. A pointer touched each word without smudging the ink. If a letter differed, a small correct sign marked the place. The scribe corrected it once the ink dried fully. Figures were checked against a short list of measures. Distances that should match were tested with a cord. Angles that should meet square were tested against a set square. Only when text and figure passed, both checks did the sheet move on. Calm review protected the work more than speed. Several sheets formed a quire, a bundle for binding or rolling. Seams were spaced so joins did not cluster. A narrow strip reinforced the start of the roll. Book and section marks appeared again at the edge. A tie cord looped the roll for safe handling. The cord was firm, but never tight enough to crease. A tag identified the intended group or class time. The roll stood upright in a chest until distribution. The chest lid closed with a quiet wooden click. The room returned to a steady rustle and faint lamp smell. In the royal quarter, an assistant handled lending and return. A small tablet listed groups and lesson hours. Before each session, he opened the chest and lifted the tag. He checked edges, seams, and headings with practiced eyes. Knife tips trimmed any rough fiber that might catch. Dry fibers whispered under the blade again. The roll slipped into a sleeve of woven linen. A copy note, or colophon, a short production record, sat at the end. It named the scribe and the day for future checks. The roll left the room with even steps. Lessons used several identical rolls so groups could work in parallel. Each group received a roll, a straight edge, and a compass. A wax tablet allowed quick notes without marking the papyrus. Students traced a figure on wax while reading the steps. When questions arose, the assistant checked the copy first. If the copy was sound, students adjusted their wax lines. After the hour, the roll returned to the chest. A brief note recorded wear, stains, or loose seams. The cycle repeated at the next hour with the same quiet order. Repairs were simple and regular. A torn edge took fresh paste and a linen patch. A lifted seam pressed flat under a board for a short time. Faded red headings were refreshed with thin pigment. If a figure blurred, a new copy replaced the sheet. The old sheet stayed as a shop reference for training. Waste never mixed with new stacks on the table. A clean cloth separated stages of work. The storage chest stayed cool and dry, away from brazier heat. A faint cedar scent from the chestboards kept insects away. Schedules aligned copying with the teaching calendar. New terms needed many early propositions and basic constructions. Midterm weeks called for problem sets with wider figures. Late terms asked for summaries and cross-references. The assistant counted rolls each evening and planned the next day. He laid out blanks, inks, and sand for morning work. He sharpened reeds and checked compass points. He aired the room so lamp smoke did not linger. The shutters admitted a small breeze from the harbor. The space felt ready before first light reached the floor. Some copies included marginal symbols for quick review. A simple dot marked a key step in a proof. A small cross noted a common error to avoid. A double line flagged a result used often in later books. These signs stayed outside the text, so reading stayed clear. They helped assistants guide groups without long speech. The marks also kept class pace steady across rooms. Teaching moved on time while copies stayed uniform. The method conserved voice and focused hands. Page by page, the habit settled in. Occasionally, a master copy was revised for better clarity. A confusing sentence was split into two simple statements. A cramped figure was moved to the next sheet for space. The exemplar was then replaced in the model chest. Older versions were wrapped and labeled for archive reference. Notes on the change sat on a small tablet in the chest. This slow record preserved order across years. Scribes could explain why a line differed from memory. Calm traceability avoided disputes and saved labor later. Distribution to distant rooms used protective carriers. A wooden case held several rolls upright. A lid slid into grooves and locked with a peg. The carrier kept dust off and prevented bending along seams. An outer tag named route and stop order. The carrier rested on a handcart along shaded colonnades. Wheels creaked softly on stone without hurry. At each door, a roll changed hands and a mark was made. The case returned light and empty to the copying room. The routine stayed predictable in all seasons. Seasonal care touched materials more than method. In damp months, sand stayed near to dry, slow ink. In hot months, shutters narrowed and work began earlier. Paste thickened in heat, so jars were kept in a cool basin. When winds carried grit, cloth covers sat over open sheets. Lamps were trimmed low so soot did not rise onto pages. Each small act protected legibility more than one might expect. The room held to its plan regardless of weather. The goal remained the same: durable, clear pages. At day's end, finished rolls stood in numbered rows. Faulty sheets were set aside for training and repair. Pens were rinsed and wrapped, knives wiped and sheathed. Compasses were capped and placed in a small drawer. The table was brushed clean of loose fibers. The floor was swept gently so dust did not rise. Shutters set to half-kept air moving through the night. The copying room settled into quiet. Only papyrus rustle and distant harbor sounds remained. Through these steps, teaching copies kept lessons uniform and calm. Scribes wrote lines that matched the model without flourish. Assistants checked figures so angles and lengths stayed exact. Knife tips trimmed edges until the roll handled well. Dry fibers whispered under the blade and then were still. The next morning, cords tied the rolls for steady use. In this way, geometry moved from table to class in quiet order. The system depended on tools, care, and patient eyes. At the head of the elements stood a calm list of definitions. Around c. 300 BCE in Alexandria, teachers began each course with these lines. The list fixed words before any proof or diagram. A reed pen moved across papyrus with even strokes. Chalked guidelines kept letters straight and level. The room stayed quiet except for soft page rustle. Lamps burned low to protect the ink from heat. Each short sentence named a basic idea in simple order. The plan was clear. Define first, then build. The first entries named the smallest ideas. A point was a position without size, no length, width, or thickness. It marked location only, not area or volume. Scribes placed a small dot, then a letter for the name. The dot helped eyes find the place again during a figure. A light prick through the papyrus fixed the location for tools. When pages were reused as models, the dot remained useful. The habit reduced error when lines returned to old marks. Pen tips tapped gently, then lifted away. Next came the line, which carried length without breadth. Its ends were points. It ran between named places. A straight line lay evenly with its points across the page. Workers drew it with a straight edge pressed on guide chalk. The edge kept the stroke from wavering in soft fibers. If the pen dragged, a small knife scraped the burr smooth. The line then received a letter at each end for reference. Readers could follow steps without guessing the path. The surface stayed clean and firm under the hand. A surface held length and breadth together. A plain surface lay evenly with straight lines in every direction. Teachers showed this on a flat board under the papyrus. A simple test used a straight edge across different paths. If light did not pass under the edge, the page lay flat. Wax tablets helped students practice broad shapes before ink. A smooth stone pressed out small rises at joins. These small acts supported clear figures later. The plane idea guided all later steps without noise. Angles received careful notes after lines and planes. An angle meant the inclination of two lines that met. When the lines were straight, it was a rectilinear angle. A right angle appeared when adjoining angles were equal. Perpendicular lines formed right angles and stood square to each other. Greater than a right angle was obtuse. Less was acute. A simple set square checked corners on the page. A plumb line tested square faces on wooden models. Measurements stayed quiet and repeatable in every season. The circle definition joined center and distance in one move. A circle was a plane figure with all boundary points at one distance from the center. That distance was the radius. A line through the center was a diameter. A semicircle was the figure cut by a diameter and its arc. A compass set the distance and traced the path with care. The metal point touched a small prick in the sheet. The leg turned slowly so fibers did not tear. A faint hiss followed the curve across the papyrus. Polygons appeared next in calm groups. A triangle had 3 sides with chines by sides and angles. Equilateral meant 3 equal sides. Isosceles meant 2. Scalene meant none. Right-angled, obtuse-angled, and acute-angled named the angle types. A quadrilateral had 4 sides with stable subtypes. A square had all sides equal and all angles right. An oblong, a rectangle, had right angles with unequal sides. A rhombus had equal sides with slanting angles. A rhomboid had opposite sides equal and angles slanting. Each name gave quick shape to later steps. Parallel straight lines were lines in the same plane that did not meet. They stayed apart however far extended in either direction. Workers tested this idea with long cords on a leveled court. On papyrus, they used equal offsets measured by a marked rod. If offsets matched along the run, the lines stayed true. Readers learned to trust a figure when parallels held steady. The calm word parallel then guided many results. Later pages would add special rules, but the meaning began here. The front matter also grouped ideas by role. Definitions named objects. Common notions set general truths. Postulates allowed simple moves. A common notion, or axiom, a shared rule accepted as true, governed equality and addition. A postulate, or demand, a basic allowed action, permitted drawing lines and circles. Scribes wrote them in red to separate roles at a glance. Lessons returned to the definitions whenever a step seemed unclear. The opening list anchored reading across the whole work. Teachers reviewed the early terms at the start of each session. A reader traced a point, then a line, then an angle on a wax tablet. Students copied the shapes in the same order on their tablets. When a new proposition used a word, the word was already fixed. A square in a proof meant equal sides and right angles by definition. A circle meant a single center and one steady radius. The calm routine saved speech and reduced confusion. The room held only brush sounds and soft pen taps. Definitions shaped how figures were planned on the page. A right angle sat at a corner, so later lines could hinge cleanly. A circle's center was labeled before any chord or diameter. Parallels were drawn wide apart to keep labels readable. Diagrams matched the text line by line without crowding. If space tightened, a scribe carried the figure to the next sheet. He rewrote its labels to keep order steady. Corrections respected the original terms. The page layout followed the meaning, not the other way. With terms in place, simple constructions gained force. To form an equilateral triangle, 2 circles with equal radii met. The centers and meeting point formed 3 equal sides by definition. To mark a right angle, a square corner set perpendicular lines. To extend a line, a straight edge continued it beyond a labeled point. Each move relied on the words set at the start. Without them, measures would drift and proofs would fray. With them, later books could climb quietly and far. Editors guarded the definitions across many copies and years. When a scribe found a variant word, he checked the model chest. The red headings in older rolls confirmed the standard phrasing. If a region used a different term, a note explained the match. The base meaning stayed the same, so lessons traveled well. Calm sameness supported readers in distant rooms. A gentle sand pour dried the last heading on a page. The roll returned to its sleeve with a soft slide. The list at the front kept its steady place. The opening definitions also shaped tools and checks. Straight edges were tested often against a reference slab. Compasses were tightened, so radii stayed firm over a full arc. Set squares were compared to a bronze right corner kept in a box. If tools drifted, figures would fail the very words that named them. Routine tests linked objects to definitions in quiet loops. The small care saved many sheets from waste. Reed pen strokes sounded gentle against a chalked guide. The workroom held to its pace without strain. Over time, students began to think in the defined shapes. A point meant a place. A line meant a path with no width. A plane meant a level field for all figures to rest upon. Angles named turns with clear bounds. Circles and polygons arrived with known parts and relations. Parallels carried a promise that lines would not meet. This firm start gave calm strength to later books. The tone remained simple and steady, from first word to last. In that manner, the elements grew from clear ground. Around c. 300 BCE in Alexandria, teachers opened a roll to a brief list. The list carried two parts with steady headings and simple phrasing. A postulate, a basic allowed action, permitted a precise construction. A common notion, a general shared rule, guided equalities and comparisons. Together they formed the support for every later result. The room stayed quiet while students traced the lines again. A low murmur mixed with the faint scrape of styluses on wax. Lamps burned low and steady along the wall shelf. The order was short, careful, and easy to check daily. Scribes presented the rules in the same layout each season. Red ink marked the headings for quick recall during lessons. The words appeared in short lines, spaced for careful pointing. A reed pen moved slowly, then paused at each period mark. Sand fell lightly to dry the surface before rolling the sheet. Assistants set spare copies on a board for student use. When edges curled, knife tips trimmed them to square form. The rolls slid back into sleeves arranged by sequence number. Paper rustled softly as the set returned to its chest. The first postulate allowed a straight line to be drawn between any points. A straight edge, smoothed along one face, guided the firm stroke. Scribes pricked small dots where the labeled points should sit. A line then joined them in one calm move across the sheet. On wax tablets, a stylus practiced the same action repeatedly. This rule turned two positions into a usable path for reasoning. Later propositions depended on that path holding firm and even. The room held only quiet, steady breaths during each draw. The line stayed clean and useful for future steps. The second postulate allowed a finite straight line to be extended. A worker placed the straight edge along the earlier segment and continued it. A light pressure kept the edge from drifting at the joint. Labels marked the old end point and the new one beyond it. On wooden boards, cords helped set longer lines for models. The extension supported triangles, parallels, and many later comparisons. Students repeated the extension until the motion felt exact and calm. No flourish appeared, only a smooth, reliable continuation. Wax crumbs gathered in a small dish beside the board. The third postulate allowed a circle with any center and distance. A compass set the chosen radius on a firm prick in the sheet. The metal point held steady, while the leg turned in one arc. The circle closed gently without lifting the point too soon. If fibers raised, a smooth stone pressed the sheet flat. Circles supported equal distances, triangles, and angle checks. They helped create equilateral figures in early propositions. Students stored the compass with the hinge tightened just enough. A faint ring sounded on the board, then faded. The fourth postulate treated right angles as equal to one another. A set square confirmed the right angle at corners of figures. A plumb line verified perpendicular walls on small wooden models. With this rule, builders and teachers spoke the same measure. Rectangles, squares, and many steps assumed that stable corner. If a tool slipped, the corner was checked against a bronze standard. The equality of right angles kept drawings consistent across copies. Rulers lay straight on the board while notes were added. The air stayed still except for a quiet breath. The fifth postulate governed lines that met or remained apart. It used interior angles formed by a crossing line to judge meeting. If the interior angles summed to less than 2 right angles, lines met. If they did not, lines could remain apart on that side. In simple teaching, a marked rod expressed the same effect. A line and a point not on it allowed only one parallel line. Later readers discussed the rule, yet workshops used it plainly. It supported rectangles, parallels, and measured grids. Chalk dust lifted once, then settled on the court. After the postulates, the roll turned to common notions. The first said, "Things equal to the same thing are equal to each other." It helped compare segments traced on different parts of a page. The second said, "If equals are added to equals, the wholes are equal." Sums of segments or angles followed this calm rule. The third said, "If equals are subtracted from equals, the remainders are equal." Subtractions appeared often when shaping new figures from old. A reed pen lifted, then set down for the next line. The fourth common notion concerned coincidence. It said, "Things that coincide are equal," meaning they match exactly. Templates of triangles or angles tested this on wax boards. When shapes laid perfectly, the check ended without extra words. The fifth said, "The whole is greater than the part." This guarded reasoning against hidden loss during constructions. It also confirmed that adding a new piece increased the figure. Teachers placed these statements under a small shared rules heading. The low murmur paused, then resumed at a steady pace. With rules set, proofs gained a clear path forward. A typical proof listed the goal, then the given lines and points. It named which postulate allowed each construction on the page. It also named which common notion justified each equality or comparison. Students copied the steps, then traced them on wax tablets. Margins held short tags like Post 3 or CN2 for recall. The structure reduced speech and kept errors from creeping in. A stylus tapped lightly 3 times to mark a finished step. The room returned to its steady quiet. Tools and checks supported the use of these rules. Straight edges were tested against a reference slab each week. Compasses were tightened until the radius held through a full circle. Set squares matched a brass right angle kept in a small box. Measuring cords were checked for stretch against a dry wooden rod. When a tool drifted, the copyist paused the day's figures. The pause protected the meaning of the postulates from harm. Notes recorded the test date on a scrap of papyrus. The faint scrape of styluses resumed once tools aligned. The postulates allowed small patterns that repeated through many books. To bisect a line, compass circles cut the space in matching arcs. A straight edge then joined their meeting points for a perpendicular. To copy a segment, a circle carried the length to a new place. Each move pointed back to postulates 1-3 without strain. The fourth and fifth guided squares, rectangles, and parallels. Common notions confirmed equality after addition or subtraction. The habits saved time, papyrus, and careful ink. Paper rustled softly as the next figure began. Editors protected the short lists across many copies and years. If a scribe found a variant phrase, he checked the model chest. The standard wording returned, so teachers could rely on sameness. Margins sometimes carried brief glosses in smaller, lighter hands. The glosses did not replace the lines, they only clarified usage. Roll cords were retied the same way after inspection. Shelves in the royal quarter held the labeled tubes in order. Lamp smoke thinned as the last roll settled in its place. The chest closed with a quiet wooden knock. In daily lessons, teachers returned to the list without drama. a student's construction that used a circle named postulate 3 first, a claim about equal lengths called the second common notion next. The order taught the habit of citing a stable reason. When a step failed, the rules made the correction simple. The figure either lacked an allowed action or misused a shared rule. The calm review kept tempers low and pages clean. Stylus marks were smoothed on wax with a flat thumb. The board felt cool and steady under the hand. The list also shaped how diagrams were laid out. Long lines began near the center, so extensions remained on the sheet. Circles were drawn after labels to avoid smearing wet ink. Right angles were placed where set squares could sit flat. Parallels were spaced for clear lettering along each run. These small choices arose directly from the 5 permissions. Equality checks appeared where common notions were easiest to see. The design of the page matched the design of the rules. Sand hissed softly over new ink, then stopped. Over months, the short list became part of quiet memory. Students could say the rules while hands prepared tools. The first 3 supported lines and circles in every figure. The 4th stabilized corners across lessons and building sites. The 5th guided grids, streets, and drawn plans without confusion. Common notions secured equality like a steady balance beam. In this way, the elements advanced with little strain. A low murmur of students mixed with the faint scrape of styluses. Outside, a sea breeze moved, and the lamps stayed calm. Around C300 BCE in Alexandria, classes began with a clear statement. A proposition, a problem or claim to show, was read from a roll. The teacher named the given data and the goal to prove. A diagram space opened on a board beside the reading desk. Chalk marked letters for points and lines in steady order. Straight edge and compass waited on the sill like quiet tools. The room held measured breaths while the first line appeared. Chalk dust rose, then settled across the floor tiles. A proof used a fixed sequence so minds could follow the path. Enunciation restated the claim in plain, compact words for memory. Setting out placed the given elements and their labels on the figure. Construction, drawing made with allowed tools, added lines required for reasoning. Proof named each step and the rule that supported it. Conclusion matched the goal and confirmed that the claim was shown. This arrangement stayed the same across many books and years. The order kept speech slow and hands moved without rush. Diagrams were drawn with care so words and figures matched well. Points used simple letters like A, B, and C set apart. Lines received 2 letters to prevent confusion during later steps. Circles were labeled by center and a marked point on their edge. Arcs were light, just dark enough to see from the benches. Right angles were checked with a small set square kept nearby. When chalk blurred, a damp cloth cleaned the field for accuracy. The class waited until the board looked clear and firm. Reasons appeared as short phrases tied to the shared rules. By postulate 1 allowed the single straight line between 2 points. By postulate 3 allowed a circle from any center with any distance. By common notion 2 allowed equals added to equals to remain equal. By common notion 3 allowed equals subtracted to remain equal. These tags sat like quiet pegs along the path of thought. They prevented drift into guesswork or hurried claims. Chalk touched down lightly for each tag, then lifted. Triangles supplied early practice because they used few strokes and many ideas. Congruence came from side and angle relations stated in earlier propositions. One result said, if 2 sides and the angle between are equal, triangles match. Another result allowed equal bases to produce equal areas under shared heights. A new construction often bisected an angle or a segment precisely. Compass arcs crossed, a straight edge joined them, and a midpoint appeared. Each step named the rule that allowed the motion. Chalk tapped once when a step was complete. A lemma, a helper result used inside a proof, sometimes appeared midstream. It handled a small need without breaking the main line of reasoning. The teacher announced it softly, drew the helper figure, and showed it. When the small result stood, the class returned to the main board. The lemma then became a tool for the remaining steps. Students marked it in margins with a short note and number. The flow stayed smooth, and the room remained quiet. A faint breeze moved the lamp flame, then steadied. Similarity and ratio entered once parallels and angles had firm ground. With a single crossing line, equal angles formed across parallel boundaries by rule. Proportions followed as corresponding sides matched through steady comparisons. A simple example doubled a length using triangles that shared angles. Another example halved a segment by equal triangles across a diagonal. Numbers on a wax tablet tracked ratios, while chalk marked the lines. Common notions guarded the equal sums and differences through each change. Sand hissed softly over a drying note on papyrus. Rectangles and parallelograms trained attention on area without measuring units. Opposite sides remained parallel, and right angles stayed equal by earlier results. A diagonal split a figure into equal triangles by shared base and height. Rearrangement then showed how one shape matched another in size. Students practiced drawing equal area shapes in different positions on the board. The names of sides and corners stayed constant through the shifts. Each adjustment cited a previous proposition instead of rough sight. Chalk dust settled in pale arcs along the tray. The class practiced a common format for every demonstration. First came the given lines, points, or angles restated slowly and precisely. Next came the construction, listing every new stroke with its reason. Then came the proof, linking equalities, parallels, and angles with short tags. Finally came the conclusion, repeating the claim now shown as true. The cadence stayed even from start to finish without harsh turns. Errors were corrected by erasing to the last safe line. Calm returned as the figure regained its clear shape. Assistants kept tools and copies in order to support the routine. Straight edges were checked weekly against a polished stone reference. Compasses were tightened, so a set distance held through a full arc. Set squares matched a brass right angle stored in a small box. Wax tablets received dated practice diagrams with neat labels. Rolls containing the elements returned to their slots by number. Knife tips trimmed worn edges so pages stayed clean for years. Paper rustled softly as the chest closed again. Training joined board work, with quiet seat work on wax. Students copied a proposition, then replayed the steps from memory. A second pass required naming each reason before drawing the line. A third pass removed the diagram and relied on words alone. The stages built a habit that traveled from room to room. Those habits allowed different teachers to use the same text smoothly. Clean copying kept figures stable across many seasons. Stylus marks clicked softly, then faded under a smoothing stroke. Proofs avoided measurement and leaned on construction and relation instead. No ruler set how long, relation set equal to this line, or twice. No protractor set how wide, angles matched by parallels or arcs. Equality was shown by overlap, shared rules, or earlier propositions. In this method, one true step supported the next carefully. If a step failed, it could not support any later piece. The class accepted that calm rule and moved again from solid ground. The lamps burned with small, steady flames. Some demonstrations reached a point where nothing more was needed. The board carried the line, which was to be shown, in brief form. The figure and the reasons together met the original claim exactly. Chalk underlines marked the goal line in a single quiet stroke. Students copied the final lines onto papyrus for later review. Margins carried short cross-references to earlier results used here. The room fell still after the last underline faded. Outside, the sea wind touched the shutters and moved on. Not every day brought new theorems. Some days trained only methods. One exercise joined two proofs to show the same result by different paths. Another removed a standard lemma to rehearse its small steps again. A third changed the diagram's orientation and checked that reason still held. These slow drills made the routine secure in any setting. The heart remained the same: given, construction, reasons, conclusion. Chalk dust rose and settled with each measured gesture. The board returned to clean space, ready for the next roll. The routine traveled beyond the room into workshops and courtyards. Builders set right angles using chords while naming the steady corner rule. Surveyors extended lines along embankments by the allowed postulate. Artisans copied equal lengths with a compass on wood and stone. Even when tasks were practical, the language stayed careful and brief. Relations guided cutting and joining more than raw measures did. Notes on scraps cited the needed proposition in simple marks. Distant hammer taps mixed with the slow rustle of papyrus. In advanced lessons, the chain of reasons grew longer, yet stayed clear. Proportions linked to similar triangles, and then to areas of shapes. Parallels set angle relations that supported ratios of sides and heights. Circle theorems used equal arcs and chords to hold equal angles. Each circle step pointed back to the compass permission already named. Common notions protected equality through addition and subtraction of parts. The pattern stayed calm, even as the reach expanded. Chalk traced wide arcs, then paused while dust settled. Quiet discipline made the routine stable in times of change. Copies aged, but careful trimming and new copies kept wording steady. Teachers retired, yet the sequence of steps remained the same. Students moved on, carrying the habit into other rooms and cities. The elements offered a calm base for any thoughtful line of work. The board might change, but the order did not drift. Figures, reasons, and conclusions returned like a daily tide. Lamp wicks were lowered, and the room cooled for night. Two simple tools guided all construction. A straight edge, an unmarked ruler, drew lines between named points. A compass, a pivoting leg with a point, drew circles of chosen reach. Postulates allowed a line between any 2 points, and a circle from any center. Nothing bore numbers or marks. Relations replaced measurements. On a board in Alexandria, a clean space waited. Letters marked points in a gentle row. Chalk lines met at clear corners. A compass clinked once. The board stayed still. The first exercise formed an equilateral triangle from a single segment. A segment AB lay ready with letters at each end. The compass opening matched AB by setting on A and B carefully. A circle centered at A passed through B in a smooth arc. A second circle centered at B passed through A in the same way. The arcs crossed at a point C above the segment. Straight-edge strokes joined AC and BC to close the triangle. Each side now matched AB by the circle rule. A quiet pause let dust settle near the tray. The next drill split an angle into 2 equal parts. An angle ABC stood wide on the board. From the vertex B, a circle cut both sides at D and E. With the same opening, a circle from D and another from E crossed at F. A straight edge, then joined B to F through the crossing point. The line BF became an angle bisector, a line that halves an angle. The two new angles at the vertex matched by equal arcs and shared steps. A soft scrape lifted stray chalk from the corner. The drawing looked steady and neat. Students then practiced the perpendicular bisector of a segment AB weighted, longer than a hand's span in chalk, with a radius more than half AB, a circle from A arced above and below. With the same radius, a circle from B arced to meet the first pair. Their intersections marked points P and Q on opposite sides. A straight edge joined P and Q to draw a single line. That line crossed AB at its midpoint and stood at a right angle. Set squares stayed aside. Only the two tools acted. The board kept a calm, balanced look. From a point on a line, a perpendicular rose by circles alone. A long line carried a point P marked near its middle. A circle centered at P met the line at A and B. Two equal radius circles, one from A and one from B, crossed above. The straight edge joined P to the new crossing point, Q. Line PQ met the baseline at a right angle by construction. Students traced the corner with a square only for a check. Small nods confirmed the fit. A breeze moved the lamp wick, then eased. From a point outside a line, another method set a right angle. A point P stood above a long baseline L. A circle centered at P touched L at 2 points, A and B. The perpendicular bisector of AB passed through P, as in the last drill. That bisector met L at a right angle without further aid. The figure showed circles and a single joining stroke. It used equal arcs to keep the work within allowed moves. Chalk dust lay in two faint crescents near A and B. The room stayed quiet. A common task copied a length to a new place. A segment CD gave a target size. A fresh point A waited for a segment of the same length. The compass set its opening from C to D with careful pressure. An arc from A marked every point at that same distance. A second line through A met the arc at a point B. Segment AB now matched CD by the circle's fixed reach. For stricter lessons, a longer construction avoided carrying distance by hand. In daily practice, the steady compass opening was accepted. Sand hissed softly over drying ink on a margin note. A parallel through a point came from an equal angle. A straight line L and a point P above it formed the setting. Near L, a small reference angle was drawn at a chosen point. With arcs and chords, that angle was copied at P. The new line through P made equal alternate angles with L. By the parallel rule, the lines would never meet. Parallel, lines that never meet, was noted once in the margin. The figure showed two clear strokes that kept even distance. The board regained its clean edge after small smudges were wiped. Segments often needed equal division into 2, 3, or more parts. A segment AB waited for 3 equal shares. From A, a ray left the segment at a light slant. The compass stepped off 3 equal marks along the ray, A1, A2, A3. A straight edge joined A3 to B across open space. Lines through A1 and A2 ran parallel to A3B using the copied angle method. Those parallels met AB at neat points, dividing it into 3 equal parts. No scale appeared, only equal steps along the helper ray. Reed pen notes recorded the count with small ticks. Circles supported figures with 6 equal sides inside them. A circle drew around a chosen center O. The compass opening matched the radius, then stayed fixed. Starting at a point on the circle, the compass stepped the same chord around. 6 steps returned to the start, marking a regular hexagon. Straight edge strokes joined the 6 points with steady hands. Each side matched the radius by construction, not by number. The result gave practice with arcs and careful point labels. A brief silence followed. Then chalk crumbs were brushed aside. Lessons repeated these drills across many days. Each class began with tool checks and a clean board. Straight edges were tested against a polished stone reference. Compass joints were tightened so an opening would not drift. Letters were chosen to avoid confusion as figures grew complex. Assistants kept wax tablets labeled with date and drill. Papyrus copies carried small drawings and short lists of steps. The work stayed patient and even. A faint sea breeze moved through the shutters and cooled the room. Applications tied the drills to work beyond the school. Surveyors marked a right angle to set a corner of a field. Builders raised perpendicular walls from a baseline on packed sand. Stonecutters copied equal lengths on lintels with a single compass setting. Carvers laid out hexagon tiles from a guiding circle on plaster. Each task used the same few strokes taught on the board. Equality came from overlap and construction, not written numbers. At day's end, tools returned to a small chest by the wall. The latch clicked softly in the dim light. Harder figures combined the simple moves without strain. A triangle's median lines met at one point, found by 3 bisections. A circle through 3 points came from 2 perpendicular bisectors. A square rose on a segment by right angles and copied lengths. A regular pentagon required angle steps and a careful chord. Each construction cited earlier drills in short, calm order. If a line strayed, it was erased and drawn again. The class paused until the figure looked clear. Chalk dust settled like fine mist along the frame. The 2 tools made a language of allowed actions. Draw a line between points. Draw a circle from a center. Intersect and join. From those moves came triangles, parallels, and many neat divisions. The craft felt steady because each step matched a known rule. The eye learned to trust crossings more than guessed measure. The hand learned to keep pressure even on chalk and brass. A compass clinked once, the board stayed still. Outside, waves sounded faint against the distant quay. In Alexandria around 300 BCE, teachers opened a new board with calm care. They drew 2 long lines, far apart but facing the same way. A third line crossed both, making corners on each side. They named this third line a transversal, a line crossing 2 lines. Chalk tips tapped equal marks where angles looked alike. Students watched the shapes without numbers. The room held a steady hush. A faint sea breeze moved the lamp flame. Dry dust lay along the frame as the board filled with signs. The special postulate, often called the 5th rule, guided the scene. It said that if a transversal cut 2 lines, and the inner angles on one side added to less than 2 right angles, the 2 lines would meet on that side when carried far. If those inner angles added to exactly 2 right angles, the lines would not meet. This rule did not try to prove itself. It was accepted so other results could follow. The board held the 2 cases in quiet balance. A reed brush cleared crumbs from the edge. Teachers paced slow examples to set the idea in mind. First, they drew 2 lines that clearly met when extended. A transversal crossed them. The interior angles on one side summed to less than 2 right angles. Small arcs showed the pair of angles. A soft tap marked the sum. Next, they drew lines known to be parallel by construction. A transversal crossed them too. Now the interior angles on one side summed to 2 right angles exactly. The chalk marked a neat rectangle to show the straight angle. The class paused. The rule felt steady and clear. From the 5th rule came many working tests for parallels. When a transversal crossed 2 lines, teachers showed 3 common angle checks. If alternate interior angles matched, the lines were parallel. If corresponding angles matched, the lines were parallel. If interior angles on the same side summed to two right angles, the lines were parallel. Each test used clean arcs and short tick marks. The chalk made a soft rhythm as angles paired. Students copied the figure onto wax tablets. Styluses scraped lightly, then stopped. A short proof fixed one test in place. Two lines sat under a transversal. The class set equal corresponding angles with careful arcs. Using earlier results about vertical angles and straight lines, the equal corresponding angles forced equal alternate interior angles. With the fifth rule, equal angles kept the lines from ever meeting. Thus, the lines were parallel. No step jumped fast. Each reason leaned on a known fact. A reed pen wrote a neat line. If corresponding angles are equal, the lines are parallel. Quiet tapping marked the end. Parallel lines supported simple shape rules that students used often. Triangles cut by parallels held equal ratios along their sides. Angles in a small triangle copied inside a larger one kept their measure. Midpoint lines across triangles ran parallel to the base. These relations followed from the angle tests and the fifth rule. Teachers sketched a triangle with a line through its middle. The new line met the sides at their midpoints. It stayed parallel to the base by equal angles. A smooth brush cleared loose chalk from the lower corner. A central result used the fifth rule in a deep way. The sum of the angles in any triangle equaled two right angles. Teachers drew a triangle ABC on a calm board. Through A, they drew a line parallel to BC. Then corresponding and alternate angles appeared by the transversal through the triangle's sides. The three interior angles at A, B, and C aligned to make a straight angle along the new line. The class marked the total with a long rectangle arc. The triangle rule would guide much that followed. The room stayed quiet and cool. Parallels also fixed distance steps across a figure. If a line crossed two parallels, equal distances between tick marks matched along both. This made equal steps for dividing segments. Teachers set a ray through a point and stepped equal marks on the ray. Parallels from those marks met a base segment and split it into equal parts. The fifth rule kept the copied angles strict, so the parallels held true. Students compared the shares with a compass opening. The points matched without strain. Sand hissed softly over a drying note in the margin. Builders favored parallel rules for walls and porticos. A baseline set on packed sand guided a second line through a chosen point. Using equal angle copies, the second line stayed parallel to the base. Columns placed along both lines faced the same way, and beams rested square. Surveyors in the delta drew parallel bounds for fields after floods. They checked by measuring equal alternate angles with simple chords. The fifth rule lay beneath each quiet act. The lamp smoked once, then cleared near the ceiling. Not every result needed the special postulate. Many early steps, like bisecting angles or proving base angles in an isosceles triangle equal, used only the first postulates and common notions. Teachers pointed this out gently. They showed where the fifth rule entered the chain, often with a small mark in the margin. This helped students see the structure of the elements. Some propositions stood without the fifth rule. Others rested on it. The order stayed calm and firm. A reed brush whisked chalk crumbs into a small tray. Later readers in the library copied this book with care. Some tried to replace the fifth rule with something shorter. Others explored figures that would change if the rule changed. In this film, the focus remained on Euclid's system in Alexandria. The fifth rule shaped straight lines on flat boards. It made triangles sum to two right angles, It fixed equal angles across transversals. The routine of class held steady through the years. Quiet tapping marked equal angles on the board. Outside, a soft breeze moved through the courtyard. Teachers closed the lesson by tying ideas to drills. They asked for a parallel through a given point, a bisection of a segment, and a test of whether two drawn lines were truly parallel. Each task began with a clean figure and ended with a small check. A compass clinked. A straight edge slid without sound. Wax tablets took the final marks. The fifth rule remained in the background like a steady weight. It kept lines from meeting when angles agreed. Chalk dust rose and settled with each measured gesture. The workroom returned to quiet order. In Alexandria, around 300 BCE, a compass point touched a board with care. A soft ring came as the metal found the surface. Teachers drew a circle by turning the other leg. A circle was all points at the same distance from a center. A radius was the line from the center to the edge. A diameter was a line through the center, meeting the circle at two ends. The room stayed quiet while the curve closed. A reed brush cleared stray grit near the edge. From these parts, they named a chord, a straight line between two circle points. They also named an arc, a curved piece of the circle. Equal radii marked equal distances. Equal distances from the center made equal chords. A short rule followed with calm proof. A line from the center to a chord at right angles cut the chord into two equal halves. If a chord was cut in half by a perpendicular from the center, its halves matched. Chalk dust rose once, then settled along the frame. Teachers next set two angles that watched the same arc. One sat at the center, and one sat on the edge. The center angle spread wide across the arc. The inscribed angle, an angle with its tip on the circle, looked across the same arc but opened less. The class saw the key result. The inscribed angle measured half the center angle on the same arc. Bands of small arcs marked the relation. From this came clean tests. Angles resting on the same arc were equal. Low voices faded as signs aligned. A special case felt useful in work and survey. When the arc was a semicircle, the inscribed angle was a right angle. A diameter fixed the semicircle above it. Any triangle drawn with that diameter as a base kept a right angle at the third point. Teachers drew several shapes to show the rule. Strings held straight by small pins confirmed the angle with care. Builders liked this steady fact for square corners. The lamp flame moved slightly as a brush whisked crumbs from the baseline. Tangents added a new line type for the circle's edge. A tangent, a line touching a circle at one point, met the radius at right angles. Teachers first drew a radius to the circle. Then they set a line at right angles to that radius at its end. The line touched the circle at one point only. It did not cross the curve. The board kept a calm outline. The short square near the point showed the right angle. A soft tap marked the join. Figures stayed clear and plain. Angles with a tangent followed a careful rule. The angle between a tangent and a chord equaled the inscribed angle that looked across the opposite arc. Teachers drew a chord from the touching point. They marked the angle with a small arc. Then they pointed to the angle on the circle that faced the far arc. The two angles matched by the theorem. Students copied the form on wax tablets. Styluses made fine lines. The room stayed still. A reed pen noted the step for later review. Inside the circle, two chords sometimes crossed. Euclid set a calm relation for their parts. Where the chords met, each split into two segments. The product of one chord's segments equaled the product of the other's segments. Teachers shaded the small lengths with neat ticks. They wrote the short equality beside the figure. This rule helped find unknown lengths when only parts were known. Proofs used earlier results about similar triangles formed by the crossing lines. The chalk moved in slow strokes. The board held its order. Outside the circle, a point could see the curve by two paths. A second, a line cutting the circle at 2 points, and a tangent met the point. Euclid showed a matching rule there as well. The square of the tangent's length equaled the product of the whole secant and its outside part. Teachers marked the whole secant from the point and its outside segment. They then marked the tangent once. The equality fixed the three lengths together. A brush cleared the margin. The class moved on without rush. Cyclic shapes appeared when all four corners of a figure touched one circle. A quadrilateral inside a circle held another steady fact. Its opposite angles summed to 2 right angles. Teachers drew the 4 points on the curve. They marked the pair of angles across from each other. The arcs they spanned filled the full circle together. That forced the angle sum to a straight angle. Carvers used this for planned frames and steps. The jungle of signs on the board stayed tidy and cool. Lengths in circles tied to area in a quiet way. Euclid later compared the areas of circles by their diameters. He showed that circles stood in the same ratio as the squares on their diameters. If one diameter was twice another, its circle had 4 times the area. He reached this by polygon steps and a method of exhaustion, taking closer and closer shapes. He did not use a fixed decimal number for the ratio of rim to diameter. That came later by other hands. The class noted only the clean comparison. Teachers next showed how to divide a circle's edge into equal parts. They set a radius and stepped it around the curve. 6 steps filled the circle with equal chords and arcs. A regular hexagon sat inside, with each side equal to the radius. From that, they could halve arcs and make a regular 12-sided figure. Similar steps built triangles, squares, and pentagons with care. These polygons gave clean paths toward area and length. Paper rustled as neat lists formed. The board held soft, repeating lines. Area inside the circle could be approached by these many-sided shapes. A polygon inside gave a lower bound. A polygon outside gave an upper bound. As sides increased, the bounds closed in. Euclid's method did not name a number for the final limit. It showed that the circle's area matched a unique value between the two. Students traced a 12-sided figure, then a 24-sided one. Differences shrank. The idea felt steady. No leaps were needed. Sand hissed softly over a damp line in the notes. Arc length and chord length compared through angle at the center. Equal central angles cut equal arcs. Equal arcs set equal chords. A small central angle made a short arc and short chord. A larger angle made a longer arc and longer chord. Teachers used this to control step sizes along rims. They also used it to space marks on circular scales. A reed pen lifted and set down in calm rhythm. The class saw how one rule linked 3 measures. The light breeze cooled the wall. Many circle results rested on triangles built from radii. 2 radii to a chord's ends made an isosceles triangle. Base angles matched by earlier propositions. A perpendicular from the center then bisected the chord. Teachers drew these helper triangles often. They kept the figures simple and clean. Each new equality leaned on a prior one. The chain stayed visible on the board. A quiet tap marked the end of a step. Chalk powder gathered in the tray beneath. Practical checks tied the rules to craft and ground. A survey ring could be set by choosing a center stake and fixed rope. Equal rope length marked the circle. A right angle could be drawn at the rim by using a diameter and a point on the curve. A tangent line could be made by setting a right angle to the radius at that point. Builders set wheel rims and arch frames with these steps. The same circle notions returned. The compass clinked once. The board stayed still. Teachers closed the lesson by linking the main circle parts. Chords compared by distance from the center. Tangents met radii at right angles. Inscribed angles stood at half their central piers. Crossed chords and outside lines shared steady products. Areas of circles matched the squares on their diameters. Each fact held its place in the order. Notes rolled into neat bundles. The lamp dimmed slightly. A faint sea breeze moved the reed blinds. The workroom returned to quiet air and calm tools. In Alexandria, around 300 BCE, teachers needed rules for comparing many kinds of size. They called such sizes magnitudes, amounts like length, area, or volume. Magnitudes could be compared even when no shared unit was known. A ratio was this comparison, taken between magnitudes of the same kind, length compared to length, area to area, and so on. The method did not rely on simple fractions. It worked even when no small unit fit both exactly. A counting cord slid with a dry, even rasp. Pebbles rested on a low tray. Euclid's text set the method in Book 5 with plain care. It built on ideas known from earlier thinkers, likely Eudoxus. The key device was the equimultiple, a whole number multiple of a magnitude. If one length was taken 2, 3, or more times, that larger total was its equimultiple. Ratios were equal when all such tests agreed. If for any choice of whole numbers, one pair of equimultiples was larger, equal, or smaller together, then the other pair behaved the same way. Sand hissed softly over damp ink as the rule was copied. This rule avoided guessing with fractions. It asked only what happens when magnitudes are repeated by whole counts. If m copies of one length exceeded n copies of another, the test looked at m copies of a second length and n copies of its partner. If the second comparison exceeded in the same way, the ratios matched. If each test matched for every whole number choice, the two ratios were equal. The idea felt strict, but calm to use. Wax tablets took the marks. A reed pen made short, steady strokes along the margin. From this base came quiet tools for handling equal ratios. If AB equaled CD, then equals could replace equals within a chain. One could invert safely, giving BA equal to DC. One could also compare the added ratios, called composition. If AB equaled CD, then A plus B compared to B, the same as C plus D compared to D. Subtraction, called separation, worked in the same careful way. These moves kept proofs moving without strain. A low murmur of students mixed with the faint scrape of styluses across wax. Proportion also guided shapes that matched in form. Similar figures were defined by equal angles and sides in the same ratio. Triangles with the same three angles stood as reduced or enlarged copies. Their corresponding sides kept one constant ratio. Builders used this for plans and scale models. If a wall's small plan showed a side twice a line, the real wall kept that ratio. Perimeters matched the same scale. Siding rods confirmed equal angles in open courts. The board held neat triangles. Chalk dust rose, then settled. Then, areas received a steady rule for similar figures. The text showed that areas stand to each other as the squares on their corresponding sides. If one triangle had sides twice those of another, its area was 4 times greater. The same held for similar polygons. For general pairs of triangles, other calm rules helped. Triangles on the same base had areas in the ratio of their heights, the straight distance to the base. Parallelograms, Four-sided figures with opposite sides parallel followed the same base height pattern. Quiet taps marked equal heights. Proportion also produced a useful length called a mean proportional, a middle value. If AB equaled BC, then B was a mean proportional between A and C. Euclid gave ways to construct this length with straightedge and compass. One standard path used a semicircle, a diameter laid with A and C joined, and a perpendicular at the join. The resulting segment gave B. With that, workers could scale parts smoothly. Such steps controlled slope in ramps, or set fair curves in frames. A compass clinked once. The board stayed still. Ratios let teachers split a given segment into parts in any set proportion. A line could be divided internally, so one piece kept a chosen ratio to the other. The same line could be divided externally to form an outside piece in that ratio too. These divisions helped place windows, steps, and beams with steady spacing. They also supported proofs about similar triangles nested on shared sides. Small triangles repeated along a ray kept the same angle at the base point. Strings stretched across the board to hold alignment. The method handled shapes beyond lines and flat figures. For solids, the text moved calmly through cylinders, cones, and pyramids. It used the method of exhaustion, closer and closer bounds, to compare volumes. Pyramids with equal heights had volumes in the ratio of their base areas. Cones followed the same pattern. For similar solids, volume stood in the triplicate ratio of corresponding edges. In later words, as the cubes on those edges. No single decimal was needed. Only the proportional relations were fixed. The lamp flame wavered slightly. Ratios also worked in circle comparisons, already used in earlier sessions. Areas of circles stood as the squares on their diameters. That result fit the wider rule for similar shapes. It did not require a fixed rim-to-diameter number. It only required that equal central angles carved equal arcs and equal chords. When students read this, their notes stayed compact. A single ratio could link many forms at once. The same steps tied rings, wheels, and round basins. Paper rustled in the shade. A small weight held a sheet flat. Some magnitudes did not share a common unit at all. Such lengths were called incommensurable, lacking a shared exact measure. The diagonal and side of a square gave one known case in earlier thought. Euclid's proportion method still compared them without naming a fraction. Equal multiple tests worked for them as well. If repeats of one outgrew repeats of the other at the same stages as a partner pair, the ratios were equal. This allowed clean, general proofs. The class avoided guesswork. The cord slid with a steady rasp against a peg. Proportion organized the elements beyond single figures. Book 6 used it to prove that parallel lines cut sides in equal ratios. It also used it to show that triangles with a shared angle and sides about that angle in equal ratios are similar. With these, map scales became calm to manage. A small plan could scale to a larger work without loss of form. Builders copied slopes, stair runs, and roof pitches by fixed ratios. A reed pen drew paired ladders of lines. The room held an even quiet. In market and survey, area could be found by reduction to a known rectangle. If two rectangles had the same height, their areas stood as their bases. If their bases matched, areas stood as heights. For oblique shapes, dissections and rearrangements placed the same content into a simpler figure. Proportion kept track of the parts. Measurement by unit squares was not needed for proofs. Ratios handled the relation in a single step. A small brush cleared grit from a straight edge. Chalk ticks marked equal spans on a scale. Across the class, the routine remained steady. First, the kind of magnitude was fixed. length with length, or area with area. Second, equal ratios were set using equal multiples. Third, safe moves, like inversion, composition, and separation, shaped the argument. Finally, earlier triangle or parallel line results tied the figure back to the claim. Each line of reason had a clear place. Nothing urgent pressed the pace. The method was strict, but not harsh. The air carried a faint sea breeze. Papyrus edges clicked softly as rolls were tied. Teachers closed their set of examples with a calm review. Proportion handled equal angles and scaled sides to define similarity. It fixed areas by squares on sides and volumes by cubes on edges for like-shaped solids. It compared circles by squared diameters. It let lines be cut in set shares, inside or outside. It allowed magnitudes without a shared unit to be compared by the same tests. Each part rested on the equimultiple rule. The room grew quiet. A counting cord slid once more with a dry, even rasp. In Alexandria, around 300 BCE, teachers used a clear rule for likeness in shapes. Similar figures were figures with equal angles and sides in the same ratios. If each angle matched its partner, and each side pair kept one constant ratio, the shapes counted as alike. This worked for triangles, polygons, and circles marked into equal parts. The language stayed plain and careful. A wax tablet warmed slightly under the hand. A straight edge lay across a low board. The compass legs rested without movement. Notes on papyrus kept the examples neat. Euclid placed these ideas in Book 6 of the Elements. Triangles were the base case because they fix shape with three angles. If two angles of one triangle equaled two angles of another, the third pair was equal as well. The triangles were then similar, and their corresponding sides stood in a constant ratio. Other safe tests followed. If the angle between two sides matched, and the surrounding sides were in the same ratio, the triangles were also similar. Reed pens tapped gently as these tests were copied in order. From similarity came stable results about size. Perimeters stood in the same ratio as any pair of corresponding sides. Areas stood in the ratio of the squares on those sides. If one triangle's sides were twice another's, its area was 4 times larger. This simple square rule guided many plans. For solids of the same shape, volumes grew with the cubes on a corresponding length, but classwork stayed mostly on flat figures. Students marked small squares on boards to show the idea. Chalk dust rose and settled with each quiet line. Builders used similarity for ramps, sightlines, and measured drawings across the city. A ramp's pitch was a right triangle with a fixed rise-to-run ratio. A small model triangle on a board could define the slope. Markers on cords transferred the ratio to the site. The larger ramp kept the same angle at the base and top. Workers checked by setting a sighting rod along the side and matching the angle on a handy tablet. The wax tablet warmed slightly under the hand as figures were set straight. Sightlines relied on equal angles made by parallel lines. When a line crossed two parallels, alternate interior angles matched. The class used this to form pairs of similar triangles without measuring every side. A short staff could copy an angle from a plan. Set against a wall or walkway, that angle shaped a viewing corridor or a processional path. The result looked calm and ordered. Sand hissed softly over damp ink as a student dried the note. Equal angles fix form. A reed cap clicked shut on the pen. Survey and height checks used similar triangles with a shadow and a rod. A vertical staff made a right triangle with sunlight and ground. A taller tower did the same. If both stood at the same time of day, the sun angle was shared. The triangles were similar, so heights and shadow lengths held the same ratio. The tower's height followed from a short proportion. Heat shimmered. A thin shadow crept across a smooth slab. The result did not need long numbers, only a steady rule and careful placing of the rod. Measured drawings on papyrus kept form with a chosen scale. A plan might set one finger's length to stand for a larger span, perhaps 100 times longer. All corresponding lengths on the real site kept that fixed ratio to the plan. Doors, steps, and roofs matched the same scale, so angles and proportions stayed true. Grids helped hold spacing. Scribes drew thin grid lines with a reed pen and pale ink. Figures placed within the grid kept their relations. Papyrus rustled softly as a roll was turned. Masons transferred profiles using simple templates based on similarity. A small wooden pattern for a cornice, scaled by a fixed ratio, set larger profiles. Dividing compasses and chords marked equal partitions along edges. Windows with equal angles at the corners and sides and set ratios matched across a court. Lattice panels followed proportional spacing, so light spread evenly. When a face was to be doubled or halved in size, similar triangles guided every offset. A compass clinked once on the board, then rested again. Teachers showed how parallel lines cut sides in the same ratios. This result, sometimes called the intercept rule, came from triangles built on a shared angle with parallels across. If a segment on one side was doubled, the matching segment on the other side was doubled as well. With that, a line could be divided into equal parts by drawing a fan of equal steps and returning a straight edge to the base. String lines stretched, and the points returned to the main line in even spacing. Tool clinks sounded, then quiet returned, then quiet. Exercises set a calm routine. Construct a triangle similar to a given one on a chosen base. Divide a segment in a chosen ratio. Form a rectangle similar to a given rectangle. And draw a line parallel to a given line through a set point. Each exercise used straight edge and compass alone, each moved by small linked steps. First, an angle was copied. Next, a side ratio was set by a proportional construction. Last, lines were joined to close the figure. The chalk ticked lightly as each checkpoint met the guide. Similarity styled round forms as well. Inscribed polygons inside a circle kept equal central angles and corresponding arcs. If one regular polygon was scaled from another, its side and radius ratios matched. Perimeters held the same ratio as sides. Areas rose with the square of the side ratio. When borders or water channels needed repeating curves, workers laid out equal chords by stepping the compass around the rim. The gentle ring of the compass point met stone, then stopped. Smooth arcs linked into the final path. Artists and scribes used scale to copy glyphs and figures onto larger walls or smaller codices. A grid on the study sheet matched a larger grid on plaster. Each square carried its part of the drawing in the same position. Angles were kept by copying the directions of short segments, not by guessing. Lines in one cell met their partners in the next, with quiet control. A soft brush cleared loose grains. A steady breath cooled the plaster. The finished image matched the plan because each part matched its ratio. City surveyors set broad causeways and canals using triangulation and similarity. A baseline was measured carefully with a cord. From its ends, two angle sidings fixed the directions to a target point. The small triangle on the tablet and the large triangle on the ground were similar. The ratio between the base on the sheet and the base on the soil scaled every other length. Stakes went in along the chosen line. Cane rustled in a dry breeze. A field mark on the cord-tied map and ground together. In class, a common pattern showed how areas respond to scale. If similar figures kept sides in the ratio m to n, then areas kept m squared to n squared. That rule supported fair sharing of fields and workspaces. A rectangle doubled in both length and width carried 4 times the area. A triangular court scaled by 3 in edge length held 9 times the area. No long tables were needed. One small square on a diagram stood for the growth in area. Pebbles clicked as a student counted the squares in a grid. Similar triangles also supported check steps for right angles and square corners. A 3-4-5 triangle, integers with sides in that ratio, gave a handy pattern, though the elements framed the logic broadly. Any scaled version kept the right angle by similarity. When marking a corner of a room, a short version fixed the angle. The larger layout copied it along longer lines. Taut chords confirmed straightness. A low murmur of workers passed along a corridor. The room geometry held steady without rush. Sometimes shapes looked alike, but were not similar. Equal angles alone did not fix polygons with many sides, unless corresponding side ratios also matched. Teachers listed the conditions with care, equal angles and sides in proportion, in the same order. When one condition failed, the shape did not count as similar. The class set examples that almost worked and then corrected them. The point was not judgment. The point was clarity. The board was wiped. Chalk streaks faded to a pale film under morning light. Similarity helped with circle-based measures learned earlier. Tangents meeting radii at right angles formed a pair of similar triangles when chords and lines were drawn. From these, equal angle theorems, chord-tangent relations, and segment products followed. Each result began with a picture and an angle match. Then the proportional sides took their place in a short chain. Area and length comparisons finished the work. A reed pen made a final dot at the line's end. The room fell still. A page corner lifted and settled. Across these tasks, the tone stayed even and patient. Similarity allowed shape to travel in size without change of form. Triangle tests, parallel cuts, and careful constructions linked plan and sight. Builders planned ramps, set sight lines, and drew measured images by fixed ratios. Scribes scaled diagrams for students, and surveyors tied tablet and ground with shared angles. The method asked for nothing quick, only linked steps. A wax tablet warmed slightly under the hand. Outside, a faint sea breeze reached the open window. Equal angles and proportional sides had fixed when shapes counted as alike. Perimeters, areas, and when needed, volumes followed their square and cube rules under scale. With these, work across Alexandria moved with quiet control. Straight edges settled flat. Compasses closed. The low scrape of a stylus faded. The light on the board softened as the class paused, and the order of similar figures rested in calm balance. In Alexandria, around 300 BCE, teachers presented a steady routine for finding a common measure. The elements described it in the books on number. The method used repeated subtraction to find the greatest common divisor, the largest whole number dividing two numbers with no remainder. Scribes laid out pairs of numbers on small boards. Pebbles marked counts. A reed pen set short notes on a wax tablet. Pebbles clicked in a cup, then rested in neat piles. The room held even light, and the pace stayed unhurried. The idea was simple and exact. If a number measured two larger numbers, it also measured their difference. So, subtract the smaller number from the larger one. Then repeat with the result and the smaller number. Keep going until the counts match or one reaches 0. The last non-zero count is the common measure. In the classes, this cycle formed a calm pattern: arrange, subtract, repeat, conclude. The pattern did not require large tables. It required attention and tidy steps. Sand hissed softly over damp ink as a line dried. Teachers showed the steps with round, friendly counts. One board might hold 30 and 18. Pebbles formed 2 rows, 30 on one side, 18 on the other. Subtract 18 from 30 and record the difference, which is 12. Next, subtract 12 from 18, leaving 6. Finally, subtract 6 from 12, leaving 6. No remainder remained. The greatest common divisor was 6. The board needed only a few marks. 30, 18, 12, 18, 12, 6, 6, 6. The last shared count fixed the answer. Chalk dust rose and settled. Another example kept the hands busy, without strain. Begin with 28 and 20. Subtract 20 from 28, leaving 8. Now work with 20 and 8. Subtract 8 twice from 20, leaving 4. Then subtract 4 from 8, leaving 4, and the match is made. The common divisor is 4. Students moved pebbles in small arcs and restored them to the cup. The room stayed quiet. A reed cap clicked onto a pen. The numbers felt orderly because each step was the same kind of step as before. The same plan worked for bigger counts because subtraction reduced them. If the larger number was far larger, teachers skipped ahead by grouping repeated subtractions at once, which saved time. This was still the same method, only faster in practice. Later, copyists wrote the steps using division with remainder, but the logic was unchanged. What measured both original numbers also measured each remainder. Each remainder became the new number to test. The chain shortened with every pass. A low murmur of students mixed with the faint scrape of styluses. Lessons tied the algorithm to ratios in lowest terms. To simplify a ratio, find the greatest common divisor and divide both sides by it. If a rectangle drew a scale of 30 to 18, dividing by 6 gave 5 to 3. Plans, loads, and prices liked short ratios because they were easier to copy onto cords and tablets. Builders marked a measuring cord with 5 knots and 3 knots to carry the same relation in smaller form. The knots lay flat and even. The cord slid with a dry, regular rasp across the board. Euclid also set the method for magnitudes that were not whole numbers. The same idea held if a pair of lengths shared a unit. Place the shorter along the longer and subtract its length. Use the remainder as the new shorter. Repeat. If the process ended, the last segment gave a common unit length. If it never ended, the lengths were incommensurable. They had no shared unit, no matter how small. This point was handled without weight. It led back to general ratio theory, which did not need a shared unit to compare sizes. Teachers kept proof steps close to the hands-on routine. One small rule carried much of the weight. If a number measured 2 others, it measured their difference. Another rule gave the stop. When the difference reached 0, the last non-zero number measured both. A final note secured the result. Nothing larger could measure both, because any larger candidate would fail to divide one of the earlier remainders. Each claim relied on the same calm property of divisibility. A reed pen stroke ended precise lines with a small dot. Boards and counters supported steady practice. Students wrote pairs of numbers along the top edge. Under each pair, they recorded the difference, then shifted the pair to use the difference and the smaller number. Columns formed on the board like steps in shallow relief. Pebbles sat in aligned rows, then moved aside. At the end, a single number repeated across a line. That number was copied into a small box labeled Measure. The work did not ask for speed. It asked for consistent steps and careful recording. The algorithm also guided measure in the field. In a storeroom, a manager checked that sacks could be grouped evenly for carts. If two counts shared a measure of 4, then stacks of 4 matched both. In a workshop, a set of planks might be cut to share a longest common length without waste, using the same subtractive plan with a measuring rod. Lay the shorter along the longer. Mark the remainder. Repeat. When the remainder matched the shorter, that length fixed the common cut. Shavings curled, then settled in a quiet ring. In geometry, the same logic appeared as a square tiling view. Given a rectangle, set the smaller side along the longer side as many times as possible. Place squares of that size across the rectangle. If a smaller rectangle remained, repeat with squares of the new smaller side. The side length of the final squares gave the common measure of the rectangle's sides. If the tiling never finished, the sides shared no unit length. Students drew neat grids to show the steps. A straight edge clicked lightly against the board's edge. In the elements, these ideas stood in books 7 and 10 for number and magnitude. The algorithm gave a backbone for many later results, such as properties of coprime numbers, numbers sharing no common divisor greater than 1, and the behavior of ratios built from them. The same backbone showed that if two numbers were coprime, then any common divisor of their combinations came from the coefficients, not from the numbers themselves. The class did not chase every thread. It marked the main one and kept its pace level. Copyists prepared short guides for practice. Each guide included 3 parts: the rule in 1 or 2 lines, 2 small examples, and 1 space for the student's own pair. The practice pairs were drawn from market counts, such as measures of grain or lengths of cord. This made the examples concrete without strain. After each set, the student wrote the simplified ratio beside the pair. A thin layer of sand fixed the ink. The board rested on the lap. Outside the window, the faint sea breeze met a dry rustle of papyrus rolls. Tidy habits supported the method's reliability. Numbers were written clearly with space around them. Subtractions were checked once before the next pass, then copied forward. A small tick marked each completed line. If a line had an error, it was scraped back with a knife tip, then rewritten with care. No marks were left floating. Each line had a role in the chain. The teacher's hand moved from board to board with the same rhythm. The room stayed even in tone. Pebbles clicked softly, then stilled. The same routine scaled to many fields of study. In music theory, whole number ratios fixed intervals and could be simplified by the algorithm. In surveying, parcel dimensions reduced to small whole number ratios when a common unit existed. In astronomy lists, long counts could be brought to a shared step for cycle comparisons. The method was general, but the class kept its footing in small, clear examples. The goal was confidence in the steps, not breadth. A student's stylus made a last careful stroke, then lifted. Teachers also showed how the subtractive pattern related to the faster division form. Instead of subtracting the smaller number many times, one step of division produced the same remainder. The boards recorded the remainder under a short line, then carried it forward to the next pair. The logic was the same. The divisor measured both the dividend and the divisor if and only if it measured the remainder. Whether by many subtractions or by one division, the chain shortened. The end result did not change. Chalk tapped once, then stopped. By lesson's end, students could find a greatest common divisor calmly and without delay. They could turn any ratio into lowest terms. They could decide whether 2 lengths shared a unit, and if so, what it was. They could tile a rectangle with equal squares until no remainder stood. The work fit the wider system. It sustained clean comparisons in geometry and in number. The method's strength lay in its repeatable steps. Pebbles clicked in a cup, then rested in neat piles. Boards were wiped and set aside. A repeated subtraction had found a common measure for pairs of numbers and lengths. The routine felt steady because each step mirrored the last. Results followed from clear rules that were stated once and then used with care. The light in the room softened. A reed pen dried on its rest. A low sea breeze moved a corner of papyrus, then became still. The room held quiet air, and the algorithm's chain of steps remained fixed in the students' minds. In Alexandria, around 300 BCE, teachers described two kinds of whole numbers: a prime divided only by one and itself, a composite divided by smaller numbers as factors. Lists on wax tablets showed small cases in quiet order: 2, 3, 5, 7, and so on. Students marked which were prime with a short stroke. They wrote divides when a test worked and leaves a remainder when it failed. Remainder, the amount left after division, appeared again and again in notes. Reed pens scratched lightly, and sand shook from a small cup to dry the ink. The class goal was simple to state. Did primes stop at some point or continue without end? The elements set a path that was brief and firm. The approach used a contradiction proof, showing that an assumption leads to an impossible result. The group first assumed that a short list held all primes. From that list, they formed a new number and tested it. If the test showed a conflict, the first assumption would fall. A low murmur of copying mixed with the faint scrape of styluses on wax. A small example made the plan plain. Take the primes 2, 3, and 5. Multiply them to get 30. Add 1 to get 31. Now test 31 by those same divisors. Division by 2 left a remainder of 1. Division by 3 left a remainder of 1. Division by 5 left a remainder of 1. Because none of the three divided evenly, the new number was either itself prime or had a factor not in the list. Pebbles clicked in a shallow dish as counts were kept. Another example used 4 primes: 2, 3, 5, and 7. Their product was 210. Add 1 to make 211. The class checked divisions again. Each trial left a remainder of 1. The number 211 stood as a prime, so a prime beyond the list now existed. The pattern felt steady and calm. Multiply, add 1, then test. If the new number survived all checks, it was a prime. If it did not, some new prime sat inside it as a factor. Dry fibers whispered as papyrus edges were smoothed with a knife. A third case showed the other outcome. Take 6 primes, 2 through 13. Their product was 30,030. Add 1 to reach 30,031. This number did not pass every test. It broke into 2 factors, 59 and 509. Neither factor belonged to the first 6 primes. The result still matched the plan. Even when the new number was not prime, it yielded a prime that was not in the list. The proof did not care which way it went. It only needed a prime beyond the given set. Quiet nods moved through the room. The general step came next. Let the list be any finite set of primes, written as P1, P2, and so on up to Pn. Multiply them to get a product n. Form a new number n plus 1. Try to divide n plus 1 by each prime from the list. Each division leaves a remainder of 1, since n is a multiple of the prime, and n plus 1 stands one more. Therefore, no listed prime divides n plus 1. If n plus 1 is prime, the set has grown. If n plus 1 is composite, it has a prime factor not in the list. Either way, more primes exist. Chalk dust rose and settled as the general case was traced. This short chain appeared in Book 9 of the Elements as a set proposition. The statement explained that there is no last prime. Students copied the wording in steady lines, then ruled a narrow margin for notes. Beside the text, they recorded the 3 model cases. They wrote list product plus 1 in a small hand at the edge. The page looked spare and neat. Near the window, a faint sea breeze cooled the room. Light touched the table. The proof stood complete in a form that fit a single board. Teachers linked this result to earlier lessons in common measure. The algorithm for a greatest common divisor showed how numbers could share parts. The prime result showed that some numbers, when fully broken down, reached indivisible parts. Factorization, breaking a number into prime factors, provided a stable base for later work. From it came clean rules for least common multiples and for reducing ratios. The class returned to small tasks that built skill: listing factors, comparing counts, and rewriting lengths as products. Pebbles moved with soft ticks inside a clay cup. Practical uses followed with quiet examples. In measuring a field, equal steps mattered. If 2 side lengths shared no common factor, their relation was already in least terms. If they did share one, factorization revealed it. In scheduling work, repeated cycles met again at a least common multiple. With primes known to continue, later counting methods could group and compare many sizes. The film stayed with simple boards and short chords, careful to show process more than claims. Fingertaps kept a slow beat as numbers aligned in columns. The Elements treated the subject without large numbers or heavy tables. That choice helped students learn the structure first. When lists grew longer, the proof still held. It did not need a special pattern of digits or any base. It relied only on multiplication and the idea of remainder. This made the result durable across eras and languages. As copies moved, the same brief steps could appear on new papyrus or parchment. The sound of pen on surface changed a little, but the content stayed steady. Scribes in the royal quarter prepared clean excerpts for use beyond the class. A few rolls carried Book 9 sections to other rooms. The text crossed from Alexandria to other centers over the next centuries. Later readers added notes in the margins about tests for primes and their growth. Those later methods were different, but they depended on the same base fact: there is no last prime. In the film, the camera held on a finished sheet. The lines were straight. The script was small and even. No flourish was needed. A teacher placed 3 pebbles to mark the first list. A student formed the product with quiet counting. Another wrote +1 in a corner and smiled without a word. The board showed each division and its remainder. The page closed with a simple line. Therefore, primes continue. Reed pens scratched lightly as margins filled with short copies of the chain. The light dimmed a little. A door moved on its hinge. Air from the harbor cooled the floor. Before the class ended, an assistant grouped tasks for practice. One group listed small primes up to a fixed bound. One group checked products +1 for fresh factors. One group compared the result with tables of common measures from the prior lesson. The room kept a low rhythm, counting, dividing, recording, then pausing. The film showed hands steady on the wax tablets and on the papyrus. No voice rose. The method itself carried the scene. A soft brush lifted loose dust from the board edge. The proof's strength came from its calm structure. It needed no special casework. It admitted no gap. For any finite list, it built a number that escaped the list. That one idea was enough. It was brief, but it changed how students thought about number supply. Later, writers called the result elegant, but the class expressed no judgment. They cared for the steps, the figures, and the habit of finishing a claim with a sure line. Outside, waves struck the key in slow measure. Inside, pens rested, and the page dried. At the board, 2, 3, 5, and 7 sat in a neat row. Below them, the product with +1 followed. A short column of remainders, all ones, lay beside it. The elements had shown that primes do not run out. The room settled into quiet air. Students tied their rolls and placed them in a wooden tray. The wax tablet kept a faint warmth from the hand. The lesson ended without hurry. Only the small click of pebbles in a cup remained. Book X of the Elements organized difficult lengths. The text called them incommensurable, sharing no common unit length. A common unit meant a small length that measured two larger ones an exact number of times. Without such a unit, division never finished. Teachers used short rods, wax boards, and straight edges to show the idea. Lines were set side by side, then compared by calm steps. A smooth stone rubbed across a line mark with slow rhythm. Reed pen notes stayed plain and short in the margin. The test for a common unit followed a steady routine. It was antipheresis, a repeated subtraction test for a common measure. One length was set against another. The longer part was reduced by the shorter as many times as it would fit. If a leftover piece remained, the roles were switched. The process repeated with the shorter pair. If the subtraction ended with no remainder, a common unit existed. If the subtraction never ended, the two lengths were incommensurable. Chalk dust rose once, then settled as figures were redrawn. A simple figure made the point clear. A square had a side and a diagonal. Students compared those two lengths by repeated subtraction. The shorter side could not measure the diagonal an exact number of times. The remainder never vanished. Roles reversed, and the subtraction still went on. The class recorded no end on the wax tablet. This showed that the diagonal and side shared no unit. Later texts call the case square root of 2, but the lesson stayed geometric. The board only carried lengths and a calm record of steps. Book V supplied a tool for work when numbers did not fit. It presented Eudoxus's theory of proportion, a way to compare sizes without fixed numbers. Two ratios were equal if, for every pair of whole number multiples, the order of greater, equal, or less stayed the same. Assistants set pebbles in groups to mark the multiples. They checked one ratio against another with quiet moves. This method allowed safe comparisons of incommensurable lengths. It did not require a shared unit. It only required clear outcomes of greater or less. Pebbles clicked once, then rested. With that base, Book X sorted many kinds of incommensurable lines. Some came from making a square with area equal to a given rectangle. Others came from adding or subtracting such lengths. Euclid used names for these types. A binomial, a sum of two lengths that could not share one square unit, formed one class. An apodum, a difference of such lengths, formed another class. The film kept the words brief, then showed the drawings. Short ticks marked where a construction began and ended. The room stayed quiet and cool. Teachers demonstrated how to name points and track parts. Letters A, B, C, and D fixed ends of lines. The text then referred to AB, BC, or CD without confusion. Students copied the pattern of naming, one figure at a time. They wrote the goal under the diagram in small script. They listed given data, the construction, and the reason. The format matched earlier proofs. It just used the broader idea of proportion for the reasoning step. The surface of the board took a careful wipe. Then the next figure began. An assistant drew a right triangle and dropped a perpendicular to the base. The parts made new lengths that Book X labeled and sorted. The same triangle gave several types, based on which parts were added or subtracted. The class kept track with short symbols in the margin. A compass point touched stone with a soft ring. Lines opened and closed in slow arcs. When two arcs met, a new point formed. The group paused to check each joint before moving on. Copyists in the royal quarter prepared clean rolls for teachers. They traced figures with red draft lines, then inked the final strokes in black. A light sand shake dried damp ink. Knife tips trimmed rough edges. The finished roll placed one proposition on each section. At the end of a long day, the copies lay flat to set. The camera held on a table where the order of types ran in a calm chain. Page rustle mixed with a faint harbor breeze that kept the lamps steady. The sorting had quiet uses beyond the class. Builders faced diagonals, sloped roofs, and ramps that did not match unit steps. Surveyors compared distances between markers over uneven ground. A column drum might be set by a circle's chord rather than its diameter. When ratios did not reduce to whole number parts, the methods of Book 5 and Book X kept order. Plans showed lengths as constructions rather than as raw counts. A wax tablet warmed slightly under the hand as measures were transferred to papyrus. Examples stayed concrete. One lesson began with a square chord of fixed side. The diagonal set the span for a roof tie. The tie could not be expressed as an exact multiple of the side. Still, the team could construct it from the side using circles and lines. Another lesson joined a square court to a rectangle of known sides. The length that squared the rectangle became a new type in the list. The result was added to an index of forms. Styluses tapped quietly as headings were updated. Not every non-whole ratio needed Book X. Some pairs shared a smaller unit after a few steps. The test separated those pairs from truly incommensurable ones. Students worked short cases on wax until the rhythm felt sure. If the subtraction ended, they wrote, "common unit found." If not, they wrote, "no unit." The two bins on the board kept the day's work tidy. A smooth stone rubbed across a line mark to clear the surface for fresh strokes. Euclid's order moved from easy to hard with steady pacing. Early propositions fixed terms and basic tests. Middle sections introduced named types and their properties. Later parts combined types and showed which could coexist in one figure. The final pages gave ways to transform one form into another through construction. Thick papyrus took the ink without bleed. Margins held small cross-references to Book 5 for proportion rules. The sound of reed pens softened as the copies filled. Lamps burned low, but even. Scribes added simple diagrams of flow. A line led from test for unit to use proportion. From there, branches reached square-based type, sum type, and difference type. Each branch ended in a proposition number. The flow sat at the roll's start as a guide. Students touched the chart before opening to the day's section. No debate rose in the room. The sequence carried the lesson. A faint salt smell drifted from stored water jars. The floor held a trace of chalk near the bench. The film paused with a return to the square and its diagonal. The board showed the repeated subtraction steps in a neat column. Beside it, a clean construction built the diagonal from the side using circles. The two scenes worked together. One showed why a shared unit failed. The other showed how to proceed anyway. Calm travel between test and construction defined this long part of the elements. The method promised clean work even when numbers did not fit. The room rested in quiet air. Later readers in Alexandria and beyond kept Book 10 in use. Some copied only the test and the first named types. Others copied the full chain. Notes in small hands linked Book X to problems in design and surveying. A few added comments on later number methods, but the core remained geometric. The power lay in sorting and in a safe way to compare sizes. Outside, ore knocks carried faintly from the key. Inside, the last line mark took a light rub. The roll closed with a measured tie. Incommensurable pairs were not a barrier in this system. They were a class with rules, tests, and steady constructions. Euclid's plan placed them in a clear map, using names, diagrams, and calm steps. The camera lingered on the table. Straight edge, compass, a cup of sand, and a smooth stone. A light wind touched the doorway. Ink dried. The long section had kept work precise when whole number parts could not. The board stood clean for the next task. The final books turned to space. They treated lines that stood above a surface and planes that stretched without end. A plane, a perfectly flat surface, became a basic setting for proof. From this base, the text defined parallel planes and perpendicular lines to planes. Diagrams fixed how edges met faces at known angles. A wooden model turned once. Quiet air moved through open shutters. Copyists set out clean boards so each face and edge could be named. Gentle reed pen strokes kept labels steady and short. The first task was to place a line against a plane. A line stood perpendicular to a plane if it met every line through its foot at a right angle. The text showed how to test this with a square set on the surface. If the square's arm met each drawn line at 90 degrees, the result held. Next came a rule for parallels. A line drawn through a given point and lying in a plane could be set parallel to a known line. The same idea worked for whole planes that never met. Chalk marks stayed thin and even. Angles in space required careful naming. Two lines crossing made an angle as before. Two planes meeting made a dihedral angle, the angle between two planes. Students learned to measure it by taking a slice with a line perpendicular to the edge. The slice turned the space problem into a flat one. Diagrams showed the hinge line, the slice, and the measured angle. Short letters marked each feature in order. The method kept comparisons clear across many cases. A light tap of the straight edge settled the board before the next drawing began. With space angles fixed, the text introduced solid figures. A prism stood on a polygon and rose to a matching face above. A parallelepiped, a box with opposite faces parallel, formed a special prism with straight, paired sides. Definitions set how edges ran and how faces matched. From these, the text proved when two prisms were equal in volume. If their bases had equal area and their heights were equal, the volumes were equal. Pebbles marked base areas, chords marked heights. A reed pen wrote equal signs in the margin with calm care. Pyramids followed in measured steps. A pyramid rested on any polygon and rose to a single top point. The text showed that a pyramid with a given base and height held 1/3 the volume of a matching prism. The proof used exhaustion, approximating by finer and finer slices. Thin cross-sections filled the height and matched between figures. As slices grew thinner, leftover gaps could be made as small as desired. The lesson stayed slow and precise. A soft brush cleared chalk from the board. The pyramid rule joined the day's list. Cones and cylinders came next, using the same strategy. A cylinder stood on a circle and rose to equal height. A cone shared the same base and height, but narrowed to a point. By steady slicing, the The cylinder's volume matched its base area times height. The cone's volume was 1/3 of the cylinder. The argument never leaped. It only refined the slices until the difference vanished. Students drew parallel lines for levels and noted equalities on each. The room stayed quiet. Sand hissed softly over damp ink and then settled. With volumes in order, the text returned to diagonals in space. A box held 3 edges meeting at a corner. The diagonal across the box depended on 2 earlier steps. First, a face diagonal was found using flat rules. Then that face diagonal and the third edge formed a right triangle in space. The long diagonal followed by the same flat rule again. The move linked plane and space without new strain. The diagram showed 3 nested right triangles with known sides. A counting cord slid with a dry, even rasp. Next came similar solids. When shapes kept the same form but changed size, their measures scaled in a set way. The text proved that prisms, cylinders, pyramids, and cones of the same shape had volumes proportional to the cubes of their corresponding lengths. The argument leaned on proportions from earlier books, and on thin slices again. Assistants arranged 3 models on the table: small, medium, and large. Edges were checked, then heights. Pebbles marked triple counts along a chord. A low murmur of students mixed with the faint scrape of styluses. The final stretch reached the 5 regular solids. A regular solid had equal, regular polygon faces, and the same number met at each corner. The 5 were set: the tetrahedron with 4 triangles, the cube with 6 squares, the octahedron with 8 triangles, the dodecahedron with 12 pentagons, and the icosahedron with 20 triangles. The text proved 2 things with quiet force. First, each could be constructed. Second, no other regular solid could exist. The model turned once more. The shutters let in a steady breath of sea air. Construction began with a sphere as a guide. A circle was drawn on a board, then lifted into space by measured steps. For the tetrahedron, equal edges on great circle paths met at 4 points. For the cube, square faces aligned with 3 pairs of perpendicular directions. Triangular faces made the octahedron from 6 chosen points. The dodecahedron needed a pentagon construction set by earlier proportion rules. The icosahedron used triangles tied to that pentagon. Each edge length came from earlier theorems. Small ticks marked where arcs met. The compass lifted with a soft ring. The counts stayed clear across faces and corners. Students checked how many faces met at each corner and which angles held. If too many faces met, the corner angle passed a full turn and failed. If too few met, the surface left a gap and also failed. The 5 cases balanced just right. A table of numbers lay beside the models. It listed faces, edges, and corners for each solid. The list fit without strain. Pens scratched lightly as margins filled with neat, small notes. Diagrams made the constructions repeatable. Copyists drew red guidelines for drafts, then black lines for results. Each figure carried short labels for edges and angles. Definitions sat above the diagram in clean script. Propositions followed in a fixed rhythm: given, to prove, construction, and reason. The last line stated the claim again in few words. Pages dried under a sprinkled dusting of sand. A lamp wick shortened, then steadied. The models rested on a flat board, each with a small tag tied to one edge. The closing proofs linked solids and plane figures one last time. A cube's diagonals met at the center by earlier space rules. A dodecahedron's edge relied on pentagon ratios from plane geometry. The icosahedron's layout followed equal triangles and known angles. Each result looked back to the first books for support. Nothing stood apart. Lines and circles from early lessons still supplied the measures for space. The system held together with quiet fit. A straight edge lay level on the bench. A compass rested open beside a cup of sand. Teachers showed calm uses for the new results. Builders planned ceiling coffers with square, triangular, and pentagonal frames. Surveyors checked parallel terraces with sighting lines across slopes. Modelers set teaching solids for basic drawing drills. Counting chords scaled models to larger works without loss of form. A wax tablet warmed slightly under the hand as numbers transferred to papyrus. No rush marked the room. Each figure led to the next with a sure pace. Outside, gulls called faintly over the harbor. Inside, the board stayed still. The books closed with a summary of space facts. Lines in planes and lines standing from planes had fixed rules. Parallels and right angles extended cleanly into 3 dimensions. Prisms and pyramids held steady volume relations. Cones and cylinders followed the same order, similar solids scaled by cubes of their sides. At the end, the 5 regular solids completed the map. A wooden model turned once more. Quiet air moved through open shutters. The last diagram showed edges and angles named in full. The roll tied shut with a simple, even knot. Lessons followed a quiet, regular plan. A small schoolroom stood near courtyards of the royal quarter. Low benches faced a smooth board for figures and notes. A reed mat covered the floor to hold dropped grit. Light reached the room from a high window, soft and even. A water jar rested on a stand beside a small scale and a sand cup. Palm leaf fans stirred. Pages lifted and fell with a dry sound. The day began without rush, only careful movements and short words. The room kept simple tools within easy reach. The straight edge lay flat, its edges checked for nicks. A compass with firm joints waited beside it. Wax tablets held practice figures that could be warmed and smoothed again. Papyrus sheets, cut square, rested under a linen cloth to stay flat. A reed pen trimmed to a narrow tip made thin lines. Fine sand set ink quickly so smears did not spread. A stylus, a pointed writing tool for wax, left clean grooves. A small brush cleared chalk dust from the board after each drawing. Morning opened with short review before new material. Students repeated key definitions from memory, slow and clear. Point, line, angle, circle, and plane returned in steady order. Postulates and common notions followed, each in a single line. The group then checked a figure from the previous day. They looked for equal angles, matching sides, and proper parallels. Any slip in a line received a fresh stroke beside it. The board showed both versions, so the change stayed visible. A faint sea breeze moved across the doorway. After review, a brief lecture set the day's problem. The example might ask for a line parallel to a given line. The teacher drew the base figure with careful, thin strokes. Steps appeared one after another, with small letters near each point. Reasons followed each construction, tied to earlier results. The talk stayed low and even, with pauses for marking. When the last step stood, the claim was stated again. No stage was skipped. The figure matched the words, and the proof matched the figure. A palm fan clicked, then grew still. Guided practice began at once. Students drew the same problem on wax, then on papyrus. Each person marked points and lines in the shown order. Pairs traded boards to check the sequence and labels. If a point strayed, a fresh line replaced it without comment. The teacher walked the room and watched for order. A light tap of the straight edge guided a correction. Compass legs lifted and set down with care so circles kept their centers. The pace stayed modest and regular. Quiet breath and gentle page sounds filled the space. Mid-morning drills practiced set constructions. An equilateral triangle came from two equal circles. An angle was bisected by intersecting arcs. A perpendicular dropped from a point to a line with two crisp marks. Each drill reinforced the rule: draw, name, and state why. The results were copied once on papyrus with thin strokes. Short headings named the problem and the steps. A date mark in the corner fixed the day's work. A brush whisked loose grit from the bench. The window's light shifted slowly along the far wall. A short pause followed. Students stood and stretched their hands. Bread and olives passed in small baskets. Water poured into plain cups from the jar with a clear note. Outside, sandals brushed the corridor floor. A messenger from the library delivered a fresh roll of blank sheets. The cord came off with a quiet snap. New sheets lay beneath a weighted straight edge to flatten creases. The room cooled as air moved through the high window. After a few minutes, the board was clean again for the next part. The afternoon turned to applied figures. A courtyard column provided a real measure for a scale drawing. Using similar triangles, students set a ratio to find height. A chord across the floor marked a sightline between 2 points. Shadows, distances, and angles were listed in neat rows. Then a box form on the table modeled space lines and planes. A face diagonal and long diagonal were drawn as taught. The set showed how plane rules helped in space. The method looked the same: draw, name, and give a reason. Oral recitation came next in short turns. Each student stated a proposition in calm phrases. Given, construction, and proof were voiced in order. Hands pointed to letters on the figure while words stayed steady. If a step missed a reason, the figure supplied it from an earlier line. A pause allowed a correction, then the chain continued. The aim was clear speech, not speed. Pebbles in a small cup counted who had spoken. When the cup emptied, the set was complete. Palm leaf fans stirred again and settled. Copywork closed the main exercises. Clean versions of today's results were written on papyrus. Margins held references to earlier propositions with short marks. A simple numeral set the sequence of the day. Finished sheets dried under fine sand, then were shaken gently. Rolls formed with linen ties and small tags. A storage list on a wax tablet matched names to rolls. A clerk checked the count and placed the bundle in a wooden box. The box lid slid into place with a soft scrape. The room remained ordered. Records and notes kept progress clear. A daybook tracked topics, drill totals, and needed review. Small slips recorded repairs to pens and the amount of sand used. When a student moved from one group to another, a mark showed it. A pottery sherd served as a temporary ticket. The sherd, called an ostrakhan, a broken piece used for writing, carried a name and date. At week's end, it returned to the basket. The system avoided loose talk. Everything that mattered left a trace on board: wax, papyrus, or sherd. Links to the library were practical and quiet. A steward confirmed paper counts and returned worn copies for scrap. When a roll frayed, its useful parts became practice strips. A senior assistant checked older geometric notes to align symbols. The elements, arranged in books, supplied the order for class. Sections on straight edge and compass work guided the drills. Space figures came after plane work, as the larger plan required. The school did not chase novelty. It kept the path familiar so each term stayed fixed. Pages lifted and fell, then rested flat. Late afternoon allowed careful correction of common slips. Parallel marks that leaned too close were redrawn with equal spacing. Points that lacked letters received short labels in the same hand. If a circle cut a line in two places, both points were named. Students wrote a final line for each figure, what was shown and why. These closing lines trained short, clear habits. A brush crossed the board from left to right, then stopped. The room breathed evenly again. The corridor outside remained calm and cool. Before dismissal, the teacher prepared the next day's plan. A wax tablet held the list: review, new proposition, 3 drills, and recitation. A small heap of pebbles marked expected steps in the proof. The straight edge's edge was checked one more time. Compass points were wiped clean and closed gently. Reed pens were trimmed and stored nib-up in a clay jar. The water jar was sealed with a fitted lid. A cloth covered the papyrus stack. Lamp smoke thinned as the wick was lowered. The routine reached beyond the walls. Builders from nearby yards sometimes sent a measured question. A short sketched answer returned on a strip, tied to a message cord. Survey lines along a canal prompted a clean drawing and a ratio check. A small scale weighed cord lengths to match drawings to ground. These tasks stayed modest and exact. The class saw that proofs gave shape to useful lines. The city's work and the school's order remained linked by quiet diagrams. The day's sunlight thinned across the threshold stone. As evening neared, students recited one last proposition in unison. Definitions returned in concise form, then the common notions. The group gathered pages, swept grit, and aligned benches. Rolls were placed in a chest with straight ties, labels up. The doorframe received a final wipe where chalk had settled. Sandals brushed dust along the threshold in even strokes. The palm fans rested on pegs, their leaves closed. The room grew still, with a faint salt smell from the harbor. The day closed as it began, quietly and in order. A short lecture set a goal. Guided practice met the goal, and review fixed it. Figures were drawn with steady hands. Reasons were stated in few words. Errors met fresh lines and then were forgotten. Records kept pace with copies and drills. In Alexandria's royal quarter, this rhythm shaped minds to careful steps. Pages lifted and fell, then lay flat. The latch slid into place with a soft click, and the work waited for first light. From late antiquity, copies of the elements traveled by steady hands. In Greek schools of the Eastern Mediterranean, scribes made new exemplars. Papyrus rolls gave way to parchment sheets stitched into a codex, a leafed book. Lines were ruled with a stylus to guide even script. Diagrams were placed within those ruled frames, close to the matching text. Red letters marked points on figures to reduce confusion. Correctors compared each page against an exemplar and noted small slips. Lamp flames hissed softly as pages dried under thin sand. Leather ties creaked as finished quires were stacked. Copy rooms followed regular tools and steps for accuracy. Parchment was scraped smooth with a curved knife and pumice. Pricking marks set margins so rows stayed straight across the leaf. A reed pen made dark strokes. A finer pen added labels on figures. Ink mixed from soot and gum held a mild resin smell. Scribes paused to test the compass point on a spare scrap. Letters for points, like A or B, landed exactly on the drawing. A second reader traced the proof aloud in low tones. Paper crackled softly as folios turned during this check. Movement of books matched routes between schools and ports. A teacher leaving one city often carried a fresh copy to the next. Alexandria, Antioch, and Constantinople shared steady traffic in learning texts. Wrapped codices traveled in leather cases lined with linen. Coastal air dried covers while ships waited at anchor. When a copy reached a new room, a clerk logged its contents. Shelves grouped mathematics apart from medicine and astronomy. Notes inside the cover recorded owners and short dates. The sequence of proofs held, page after page, without break. By the 5th and 6th centuries, translators also worked in Syriac. Syriac schools in the Near East trained readers for Greek science. Some mathematical terms kept their Greek form with a short gloss. Others received plain equivalents in the local tongue. Marginal notes explained a difficult step, then pointed back to earlier books. Diagrams remained the same in outline and labels. A careful hand drew circles and triangles on scraped parchment. Dry fibers rasped lightly under the pen's tip. Pages rested under a board to keep them flat overnight. Across the 8th and 9th centuries, paper became common in workshops. Papermakers pressed linen fibers into sheets, then polished them smooth. Paper took fine ink lines and accepted erasure with a light knife. Binders folded sheets into gatherings, then stitched spines with linen thread. The change from parchment to paper lowered weight and cost. Copying moved faster without loss of clarity. Stacks of trimmed leaves sat under a smooth stone to cure. A light brush lifted extra starch from the finished surface. Paper edges clicked as piles were squared for storage. In Baghdad, under early Abbasid patrons, translation became organized work. A bureau often called the House of Wisdom, a translation workshop, guided projects. Greek mathematical texts reached the city by traders and envoys. Translators used Greek exemplars, or Syriac versions when Greek was scarce. They worked in pairs to catch slips and secure meanings. One read the source line by line. One set the Arabic. A third worker placed diagrams and letters in the proper places. Inkstones tapped gently as nibs were refreshed. The room stayed quiet except for turning folios. Several scholars produced notable Arabic versions and revisions. Al-Hajjaj ibn Yusuf prepared early translations and corrected them later. Thabit ibn Qurra revised wording and added helpful notes on difficult steps. Their aim was steady: keep the order of books and the strength of proofs. Teachers in Baghdad then used these copies for class and practice. The text structure let groups progress at a measured pace. When a proof ended, the Arabic matched the Greek step for step. A small seal marked completed gatherings in red. A leather strap closed the book with a soft pull. Workshops followed routines to keep diagrams exact on the page. Scribes ruled 2 columns to balance text and figures. If a drawing grew large, it moved to a clear half page. Letters on the drawing appeared in red for quick finding. When a figure repeated, a short note said, "as before," and cited a line. Students added small dots near key steps during lessons. After reading, they erased those dots with a gentle rub. Burnishers swept lightly to seal the ink and calm the fibers. The folio felt cool under the hand. Commentary formed a second layer around the base text. A gloss, a short note, explained a term or reminded a prior result. Longer comments, called shar, discussed choices of construction and order. Some pages carried wide margins for this outer writing. Teachers placed a fine line between Euclid's words and added remarks. The habit preserved the base while allowing careful help. Diagrams were never redrawn in the margins to avoid confusion. Instead, a reference letter pointed back to the main figure. Reed pens scratched lightly, then rested in small stands. The elements also supported work beyond the schoolroom. Builders used similar triangles to plan levels, ramps, and shadows. Surveyors set chords along canals and compared ratios for gradients. Astronomers turned to geometric results to design instruments. A quadrant and an armillary frame relied on clear angle relations. Observatories near the city tested alignments with noon shadows. Quiet assistants reported measured arcs and chord lengths using standard terms. The same proofs guided both copy rooms and open courtyards. The uses differed, but the order of steps stayed constant. Books moved outward from Baghdad in several directions. Caravans carried copies to Damascus, Aleppo, and Cairo. Westward routes led toward the western Mediterranean by steady stages. Scribes in those cities made new copies from the Baghdad versions. Some included both Arabic and Greek on facing pages. Others preserved only the Arabic, but kept the diagrams unchanged. Owners added short ownership lines inside the cover. The smell of leather, paste, and ink marked the shelf area. Paper crackled softly as caretakers inspected edges for wear. Care of books followed a regular craft. Bindings were repaired with new thread when cords loosened. Torn leaves received patches of thin paper pasted with starch. A bone folder pressed joins until they dried smooth and flat. When a worm track crossed a letter, a scribe restored the stroke. If margins darkened, edges were trimmed and resewn. Cloth wrappers kept dust off the covers in dry months. Title tags tied to spine cords for quick finding. Ledgers in the workshop recorded repairs and loans. The low scratch of a quill counted each entry. Variants arose, yet the base stayed stable through checking routines. Collators set two copies side by side and read them together. When a word differed, a small mark noted the choice. Diagrams were measured against standard models using a thin thread. If a circle ran wide, it was redrawn to match the measure. A final leaf listed corrections in their places. Students learned to use these lists when copying again. The work felt patient and exact, not hurried. Lamps hissed softly as the last pages dried. Later centuries added more layers without erasing the core. Commentators in Persia and Central Asia wrote new guides for teaching. Some reorganized examples while keeping the same proofs. Others expanded notes on parallels and incommensurable magnitudes. The base sequence of 13 books remained the anchor. Additional books, sometimes attached, circulated in a few centers. Their pages echoed the style of the earlier parts. Index slips helped readers find a desired proposition quickly. The slip rustled, then slid back into its narrow pocket. Through these movements, the elements kept a clear identity. It was still a chain of definitions, postulates, and proved steps. Teachers recognized the opening lines at once, in Greek or Arabic. Builders recognized familiar figures for sightlines and level checks. Scribes knew where to place letters to match the text. Students expected a proposition to begin with, a given and end with a claim. The book's order guided the pace of learning and work. Paper stacks settled under weights. The room grew quiet after the final turn. By the early Islamic centuries, the manuscript tradition felt well established. Cities held shelves with multiple copies and known commentaries. Translators' names appeared on opening leaves with short praise lines. Workshop marks recorded dates and materials for each copy. The volume's weight, size, and script style signaled its origin. All these details formed a steady map of its path. When the folios opened, the same diagrams met calm eyes. Paper crackled softly as folios turned. The sequence of proofs continued without strain across languages and time. The room sat within the royal quarter of Alexandria around 300 BCE. Afternoon light reached a low table with space for figures and notes. A reed pen lay near a dish of soot and gum ink. A straight edge, unmarked by scale, waited along the board's edge. A compass with one metal point stood half open on the surface. The air moved slowly from the harbor and cooled the walls. Page fibers rustled once, then settled into quiet lines. Euclid's system held the room's routine more than any one face. Definitions set meanings for point, line, and angle at the beginning. Short postulates gave allowed moves like drawing a line or a circle. Common notions added simple rules for equality and subtraction. With these, demonstrations advanced from given data to a shown claim. Steps were linked so each line matched a reason above or beside. Chalk dust rose and fell as figures gained and kept their form. Tools supported the calm order without calling attention to themselves. The straight edge guided lines from mark to mark without numbers. The compass rotated smoothly to repeat a fixed distance anywhere on the board. Wax tablets took trial figures before a final drawing on papyrus. Sand dried fresh ink with a soft hiss and left no stain. A damp cloth wiped wax surfaces when a trial no longer helped. The room stayed spare so the figure and the words could agree. Each proposition followed a steady pattern that invited careful attention. A heading named the goal in a short, plain sentence. A given set the starting facts and the objects to be used. A construction added lines or circles according to earlier postulates. A proof tied equal lengths and angles into a small chain of reasons. A close confirmed that the shown figure matched the claim exactly. Letters placed on points let the text and drawing move together. The larger work preserved this pattern across many books. Early parts treated triangles, parallelograms, and basic area relations. Later parts handled proportions, similar figures, and careful sorting of ratios. Number theory sections considered common measure, primes, and factor relations. A long treatment managed lines that shared no unit of length. Final books described parallel planes, angles in space, and regular solids. The order felt stable and complete for teaching and for use. The teacher's bench returned to simple constructions for a quiet close. An equilateral triangle began from a single straight segment on the board. The compass point fixed one end and turned an arc with measured ease. A second arc crossed it from the other end at a clear point. Lines connected the new point to both ends of the base. The three sides matched by construction from the same distance. The compass clinked once, then rested on the wood. An angle bisection followed with the same calm pace and care. 2 points on the sides of an angle were chosen at equal distance. A pair of arcs crossed between them at a single meeting point. A line from the angle's vertex to that point cut the angle into two. The equality traced back to equal distances and simple triangle facts. The move would help later sight lines and measured turns on plans. The board stayed still as the ink dried in thin strokes. Plain results kept their place among these constructions without strain. When a triangle's angles were added, 2 right angles appeared in total. The proof used a parallel through a vertex and matching interior angles. Each reason matched a line, then joined the next without hurry. The sum did not depend on the triangle's shape or size. The room's air shifted once as a shutter moved on its cord. The figure remained clear after a light brush lifted dry grains. The method proved helpful beyond this small room of lines. Builders used similar triangles to set ramps to stable gradients. Surveyors placed cords along canals and compared ratios for level runs. Astronomers planned sighting frames with fixed right angles and arcs. Each craft borrowed the same steps and terms to keep work steady. The elements gave shared language for lengths, angles, and comparisons. A wooden model of a cube turned once, then returned to the shelf. Across later centuries, the same bench scene could be found elsewhere. Greek copies became Syriac and Arabic copies in careful workshops. Commentators added glosses around the base text, but left figures intact. Teachers spoke different words, yet followed the same order of steps. Translators kept diagrams near the matching lines for quick reading. Paper replaced parchment in many rooms, yet strokes looked familiar. Paper edges clicked softly as a folio turned to a known page. Early printers arranged the work into movable type and woodcut figures. Diagrams sat within the text, so letters matched their points. Margins carried short notes for finding a prior result. Index lists sorted propositions by number for quick return. Binding cords creaked lightly when volumes opened for class. The printed page differed in craft, but not in sequence. The method of proof continued with the same steady breath. The bench still showed simple care for working surfaces and tools. The straight edge's edge was checked against a known line for warp. The compass joint received a touch of oil to hold its spread. Pens were trimmed with a small knife to a clean, narrow tip. Ink received a drop of water to flow, not bleed. Wax tablets were warmed by the hand to take gentle marks. The careful kit made figures precise before words met them. A closing figure brought the parts back into one quiet view. A circle stood with a chord marked by 2 small letters. A perpendicular from the midpoint rose to the circle's edge. Equal triangles on both sides fixed the right angle at the base. Tangent and radius met at right angles by an earlier result. From these, segment relations followed in short, accurate steps. The compass point touched stone and gave a soft ring. The film kept attention on the bench rather than distant halls. Outside, the royal quarter held libraries, colonnades, and busy workshops. Inside, the room kept only enough for lines, circles, and proofs. A scroll lay bound with a thin tie beside a small weight. No page told a story beyond the calm chain of reasons. The scene felt complete without display or crowd. A faint sea breeze crossed the sill and moved one edge of papyrus. The elements had traveled, yet the method here stayed unchanged. A given, a construction, and a proof made a regular path. Equalities joined quietly to show what the figure already suggested. Postulates allowed limited moves that proved surprisingly wide. The system's strength came from its careful start and slow growth. Teachers repeated the sequence until each step felt certain. Light dust fell to the floor and stayed still. The camera's view returned to the neat figure on the board. The compass lay folded, with its legs aligned along the straight edge. A reed pen rested beside a small dish of ink and water. The page showed letters placed without crowding at corners and midpoints. A tiny scrap carried a list of earlier results cited in order. Nothing hurried, nothing shifted from its place. The room's quiet matched the figure's clear balance. Across time, readers recognized this calm arrangement of parts. Students traced lines with their eyes and followed reasons with their hands. Builders checked a drawing and agreed with a short, firm step. Translators placed letters on diagrams to keep meaning exact. Printers aligned figures so proofs read smoothly from start to end. The same method joined all these small actions without strain. The bench scene carried that joining in simple objects and motions. The closing minutes held no new claims or large designs. A reed pen hush blended with light page turns near the table. Evening air moved through the shutters with a slow, steady sound. The figure stayed in place, while ink dried to a matte line. The straight edge touched the board with its flat edge and waited. The compass shifted once, then settled into a narrow rest. The film let these small sounds continue for 1 to 2 minutes. When the paper's surface felt dry, the page lay gently on the stack. A hand placed a thin weight at the corner to keep it flat. The shutters stood half open as the air cooled toward night. No further lines were needed to hold the proof in order. The elements, arranged long ago, remained clear in their quiet chain. The room held the bench, the compass, and a neat figure. The evening breeze moved softly, and the pages turned in peace.